Oh, yeah.
Okay.
Okay, so, well, welcome, Martin. It's good to have you here. So I've been in contact with Martin since about 2012, I think, through, or no, what am I saying, 2020.
Yeah.
I got 2012 on the brain there. So, yeah, so we got in touch because we were doing, as you said, Rajan, similar things to do with imaginary numbers and basically their multiplication through XOR or XNOR, depending on how you look at it. So Martin's given us a bit of his background there previously, including his degree in chemistry and professional training practice of patent law in the medical field, which is interesting. And then you also mentioned that you have some interest in anthropology and that you spent several summers living with the Maasai in Kenya and the Dayak people in Borneo. So to study their belief system. So that's fascinating as well. But we probably won't have time to get into all of that, but maybe another time, because today we're going to be looking at counting, which sounds very simple, but I think we're going to be a bit surprised. Okay, would you like to take it away, Martin?
Right, let's see if I can remember how to get to my slideshow. Right, I think I click present. We do share screen and share screen. And then who wants to share Chrome entire screen? And I've got to open. Now I've just got to remember how we do this entire screen. There we go. Share. Are you seeing my screen? And now I need
to... yeah, okay. I see it. So we're just going to add it there.
Open this, start slideshow. So can you see the slides?
Yes.
Excellent. All right. So I will begin then. So what I'm going to do in this presentation, or seek to do, is identify a symmetry problem inherent in the system we use to count objects, specifically in the way it treats the two sides of a distinction. I want to propose a solution to that problem. Now, the problem solutions are extremely simple, but they're hidden in plain sight. And I'm not trying to persuade anyone that this is right or anything. I'm just trying to convey an idea I've had. Basically, umpteen years ago, after my chemistry degree, there were new jobs in chemistry, and I ended up with Deloitte on a management consultancy training scheme in London. And I was in a class on bookkeeping, and what happened was I had a problem. Well, there was a symmetry problem with double entry bookkeeping. And I got very excited about this. And my boss thought I'd gone mad and forced me to go to the accident emergency to see a doctor. And he called my parents to tell them I'd gone mad. The doctor said, "You're just excited with an idea you've had, and go away." And I was so mad with the boss called my parents that I quit the job. And I ended up with a career in patent law. What I want you to imagine, because I sense this idea, is your two hands coming together as if you're clapping and stopping, but at the time they come together, they split apart. So imagine the two hands as representing the act of negation, or posting a debit to a credit or credit to a debit, the act of negation, and that instead of you collapsing to singularity, you jump apart, your hands jump apart front and back, so you've got still a distinction, still two objects, two zeros. I'm going to try and explain the idea through meanings. As a patent agent, you have to write patent specifications and be very clear what the meanings are of the terminology you use. So symbols, which we use, are tethered to meanings. A symbol is an object identified using a physical property to draw a distinction between what it is and what it is not. Now, we normally just think all that it's a distinct thing, but it's distinguishing what it is and what it is not. And here's an example of objects identified physically. So you've got letters, what we call letters, and then compound letters, which are words. There's a symbol here with a a red cross, and there's a very complex physical object which is very carefully designed so you really can't counterfeit it. But these are all physical things. You're detecting them with your senses physically what they are and what they're not. And by meaning, I'm talking about a disembodied, i.e. not physically embodied at all, abstract idea identified using its interactions with itself and with other meanings to draw a distinction between what it is and what it is not. And examples of these might be the concept of nothing, meaning the difference between two objects that are the same. So if one is the same as one, then the difference between one and one is 0. Another abstract idea is the square root of -1. We know that I times I is -1, or I times I plus 1 is 0, because 1 is the same as I times I, minus. So those are the two logics. So construction of meanings. Meanings interact to construct a system. That's how they work. An example of meanings interaction across system is the truth table for the logic gate exclusive OR, XOR. And the meanings of the symbols, which are same and different, are mediated by the ordered drawing and clearing of distinctions. Let's look at the truth table. So we have two inputs in a truth table and an output. So if we input 0 and 1, the two are distinct, so we output 1. 1 and 0, 1. If the symbols are the same, 0 and 0, we output 0. If the same again, 1 and 1, we output 1. So out of this system, we can conclude that 0 means the same and 1 means distinct. Each symbol meaning interacts with itself to output 0 and with its opposite to output 1. The meanings for 1 and 0 arising from the truth table XOR form our basis for counting, arithmetic, and equations. So we count objects, symbols, or meanings to which we have tethered the meaning distinct. And this is the definition of a countable object. An countable object is one we count objects that are distinct. Once we've counted something in a group, once we've counted it once, we can't count it again. It's no longer distinct. So just a nice example. Here we can see 4 physical objects, sheep, 1, 2, 3, 4. And we can abstract that information or convert it into the symbols, 1, 1, 1, 1. And then the logic says, right, 1 plus 1 plus 1 plus 1 is 4, and 4 minus 4. 4 is the same as 4, so 4 minus 4 is 0. We're using the logic of XOR here, and that's where the 0 is coming from. So as we count each sheep, we clear the distinction between what that sheep is and is not. And we record this by drawing a distinction between 1 and 0, meaning distinct object and same. So the truth table for XOR contains our basis for double entry bookkeeping and for treating the signed integers +1 and -1 and 0 as ordered pairs. So let's just look at the truth table again and see how that works. So we might represent +1 as the ordered pair, 0 on the left, 1 on the right. -1 as 0 on the left, as 1 on the left, 0 on the right. And then if we just see how these interact, 1 always sort of, if you like, trumps 0, and so 1 goes into the output, 1 over 0 goes to the output. So 1 and 1 are the same. So the ordered pair 1, 1 is treated as 0, equivalent to the ordered pair 0, 0. We draw no distinction between 1, 1 and 0, 0. And it's working like a pair of weighing scales. And probably historically, this is where this has come from, way back from ancient traders, hundreds, thousands of years ago. So the signed integers correspond with tip to the left of a balance and tip to the right, and 0 corresponds with having equal or no weights on each side. So two weights of equal magnitude or no weights at all. They're both 0. And here's a thought I want to just hold on mind for later. A distinction is defined by a relationship between the two symbols 1 and 0, each of which means itself, not the other. One symbol alone does not suffice, I'm suggesting. The mutual negation of +1, represented by 0, 1, and -1, 1, 0, to afford 1, 1, equivalently 0, 0, clears a distinction. The creation of plus 1, 0, 1, and minus 1, 1, 0 out of 0 draws a distinction. Something's missing, I think, and I think there's a symmetry problem. We do the same when we create money and debt out of nothing, and banks do it. The counting system that we use treats the sheep as if each is a distinct object in a sea of nothing. However, if we were to count the sheep in a ring, we could count either the sheep or the crossings between them. Each sheep object would then have a not object counterpart. So I can count the objects 1, 2, 3, 4, but I can in any order, it doesn't matter. As long as I keep the crossings, I get to 4. So I can count either. And when a sheep or crossing is counted, the distinction that had been drawn between what it was and what it was not is cleared. The cleared distinction is deemed to form part of the sea separating the remaining uncounted sheep. So the cleared distinction, that is, for example, the negation, like the negation of plus or minus 1, is conflated with that part of the distinction which is not a sheep. We're using the same term to mean two different things. I think this is a symmetry problem, and the root of the problem, I think, lies in exclusive use of XOR on the concept of a balance to draw and clear distinctions. Incidentally, I think this is a root cause of inequality in our society. That's a bigger thing. So tethering the meanings of the symbols 1 and 0 to distinct and same, respectively, is quite arbitrary. We could use as our basis the mirror opposite truth table for X, which is XNOR. So here's the XNOR logic gate. Again, now we have input 2 of 1 and 0. We get output 0. So everything is flipped in the mirror. Everything is now has the opposite. So now 1 means the same and 0 means distinct. So we could use the truth table for XNOR equivalently to form basis for counting, arithmetic, and equations. It doesn't matter because these are just physical symbols. They have nothing that links them conceptually to their meanings. They are just physical objects, and the physical properties of those objects have no relation to the meanings and the system of meanings that we generate. So the truth tables for XOR and XNOR are mirror images of one another. They're mutually exclusive. And the symbols from which they're constructed could be two-sided, front and back, like coins, one side of which is viewed directly and one in a mirror. Remember, a mirror exchanges front and back, not left and right. Remember, there's a nice little video by Rich Feynman on this that reminds people that front and back exchange. So if you imagine the XOR table on the left, and then you imagine looking at that same table in a mirror, you'll see the XNOR. So the one underline on the left in the mirror, the same object, will be one without the underline, and so on. They're all mirror images. Each side of one underline can be related physically as the two local sides of one object, and in meanings locally as each meaning itself, not its mirror counterpart. So there is a relationship as if the two local sides of a Mobius strip, which has only one global side. And you make a Mobius strip by taking a strip like this. I've written one underline 1 on that side. On the other side, I've written 1 underline 1 underline. What you do is you twist each of the ends through 90 degrees or one end through 180 degrees. Yep. And then you draw to form a Mobius strip. As you go round the Mobius strip twice, you would go 1 underline 1 underline 1 underline. You go around through 6 altogether. They're also related as the two mutually exclusive enantiomers, that's left and right-handed forms of a chiral tetrahedral molecule. More on that follows shortly. This was something that really got me into this idea. So to revisit, symbols, we tether symbols to meanings, and conventionally we have an absolute meaning tethered to each symbol. So if we tether symbols to meanings generated in XOR, one tethers to distinct and one underline would tether to same. But if we do it in XNOR, we will go 1 underline tethers to distinct and 1 tethers to same. So far, these are mutually exclusive ways of drawing distinctions, representing distinctions. But altogether, what we have is one object which presents physically with two local sides, each of which can be tethered to mutually exclusive meanings generated in either XOR or XNOR. I've just done a little table there, just to get the idea across, that you have one generating XOR, one generating XNOR, one underlined in XNOR, and one underlined in XOR. So we've got four objects, which is a quaternion. And each of the four objects has two inputs, two generators, for one of X4 and XNOR, and is generated pairwise with its mirror opposite counterpart by the other of XOR and XNOR. So again, same relationship, four objects, four inputs. We're dealing with altogether four objects. When I was looking for an idea for a name, what I was dealing with, I came up with Karokai. The symbol kind of maps to these four objects, and it's also a bit like the yin yang symbol, where you've got the two fish with the two eyes, because kind of that's how I see all these things being connected together. Chiral being handed, kind being movement of the hands. So chirality, just so we all understand this. So if you extend your left and right hands forward towards the screen, so your wrist comes back to you, your first fingers, the thumbs, and the second fingers are on the point there. You will see that your hands fit. Were you to then take, let's say, your right hand and bring it round to face your left hand, you'll find that everything overlies. But your wrist now is, one wrist is projecting away and one wrist is projecting towards your body. So here are two chiral tetrahedrons that fit that pattern, and you'll see that if both things are projecting towards you, then the order of the green, yellow, blue is flipped. If one projects forward, you want away, then it's the same. And these two objects you can imagine interpenetrating so that they form a cube, the corners of a cube. So if we look here, you can see minus, 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 minus. That's this handed form, and its opposite handed form is here, plus, 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 plus. And each face of this cube then has two opposed parts which are of one sign, and two opposed parts which are the other sign. So they all go minus, plus, minus, plus all the way around. Now, four objects can be ordered in 4 times 3 times 2 times 1, 4 factorial ways, that's 24. However, if the four objects are treated as forming a ring, then there are 6 ways of ordering them. The number of generators of the symmetry group of order 4 is 6. And here we can see that this in action. We think of these objects as being numbered now instead of colored. You have 1, 2, 3, 4 in the face projecting towards us, and then 1, 3, 2, 4, and so on, going around the different faces of the cube. So let's return to the truth table XOR and XNOR, which we recall contain 4 different inputs and 4 different outputs. The ones and one underlines each map to the 4 corners of a chiral tetrahedron. The 6 rows map to the 6 faces of a cube, defined by interpenetrating tetrahedrons of opposite chirality. This is not immediately obvious, but it does work. So on the face, you see, well, all the signs in these different rows don't match that pattern minus, plus, minus, plus. But here's how they work. So if we look, say, the face 1, 3, 2, 4, it's got 3 and 4 underlined and 1 and 2 not underlined. So if we sort them into the order 1, 2, 3, 4, we now end up with 1, 1, 1 underline, 1 underline. And similarly, all the other faces, if you take that cube and you reorder, if you maintain the order 1, 2, 3, 4, then you will flip all the order of the ones and one underlines, just like as you're going through truth tables, logic tables. Now, if we place the truth tables XOR and XNOR one over the other, while respecting mirror symmetry, so I've got 2 tables side by side, each is the mirror image of the other, so it's actually the table viewed in a mirror. They define a 6-membered cycle that oscillates between XOR and XNOR. The rings contain interpenetrating XOR and XNOR truth tables. just like the cube contains interpenetrating enantiomers of the plus and minus chiral tetrahedrons. So if you take any two adjacent rows as inputs, if you go in one direction, it'll operate in XNOR, and the other it'll operate in XNOR. And from that simple recursive process, you will generate the entire table and the entire cycle. And you can see how it's controlled. See on the left table, top right, one underline, one line, and one underline. That's so you run down that. So if we start with the second and third and go up there, that's one logic. But then if you take second and third and run down, 1, 1, 1, coming down, that's the second column. You see 1, 1, 1. That's really the reverse logic. And altogether, the table, you just oscillate XOR, XNOR. So now the meanings for one and one underline are no longer defined absolutely, but locally depending upon their generators. So together they define a system controlled by the properties of symmetry of order 4. They're mediated by ordered drawing and clearing of distinctions. Now my time here. Referring again to the counting of sheep, each sheep and crossing can be represented by the first rows in the rings. Counting a sheep rotates the rings down one row. This corresponds with exchanging a 1 and a 1 underline, affording 1 and a 1 or 1 and a 1 underline. Essentially, you're clearing one distinction and drawing another, both sides, each time you count. So you go from sheep to the symbols 1 on 1 underline, and then if you did another, let's say you wanted to model another arithmetic operation where you've subtracted a 1 from a 1, you would go down another row. And the rings can be represented by a pair of diagrams in which each row in the ring is represented by a symbol. So counting rotates both rings by one symbol. I've just done this I, J, K, I, J, K, but it's I, J underline K, I underline J, K underline. And you'll see that they're actually they're rotated effectively halfway round. That's their relationship. So what I've been presenting is a system for counting that treats the two sides of a distinction symmetrically. I'm saying there's a symmetry problem inherent in conventional mathematics. Something's missing. It's missing because we're relying on XOR to assign absolute meanings to symbols representing same and different. I'm saying we conflate a clear distinction, which is the product of mutual negation, with the absence of a distinction, which is defined only in relation to the presence of a distinction. I'm saying the solution is to use a system for counting in which distinctions are drawn and cleared using both XOR and XNOR, such that two inputs always generate two outputs, one in XOR and one in XNOR. So recall I said right at the beginning in this class on double entry bookkeeping, I had this idea of my two hands coming together, and instead of just disappearing, including a distinction as a debits and credits cancelled or +1 or -1 mutually negate, the hands jump one forward or one backwards. So you still have two distinctions, two zeros. So what I call chiral kind, movement of the hands, as I conceived it, is an apparatus for counting distinct objects that treats the relationships distinguishing the objects symmetrically, which XOR alone does not. It records the clearing of a perceived distinction between what is and what is not a distinct object, using interpenetrating truth tables for both XOR and its mirror opposite XNOR. And as it records the clearing of a perceived distinction, it draws a new distinction. And it comprises a pair of mirror opposite rings, each consisting of 6 rows of 2 1s and 2 1 underlines, the arrangement being such that any 4 adjacent rows contain the truth tables for both XOR and XNOR. And it records the clearing of a distinction by rotating each of the rings by 1 row, and this exchanges 1 1 for 1 1 underline in each of the mirror opposite rings. So in this system, there's no absolute zero or nothingness. Every meaning is defined relative to some other meaning. Every meaning and operation has a mirror opposite dual. So arithmetic is performed not by negation, but by rotating counting rings. So when an object is moved from one category to another, as when a sheep in a flock escapes from a first field into a second, the sheep is not negated in the first field and recreated in the second. The counting rings are rotated. So this is complementary to arithmetic. It would like arithmetic, but there's no zero. absolute zero. Right, so having just talked about counting simply, I now want to jump to something else I've found. The idea the system of counting is controlled by the symmetry properties of the symmetry group of order 4, which has 6 generators. And the symbols in each row of the counting system have the same mutually exclusive meanings. However, the meanings can get mixed up. And this is potentially a very useful property. And I originally applied this for solving the double coincidence of wants problem inherent in barter, which is presently only solved by money and debt. So let's first return to the logic gates. There are 6 logic gates in total, of the number of generators of the symmetry group of order 4. Each logic gate has 4 pairs of inputs and 4 outputs. In 2 of the logic gates, the meanings of 1 and 0 are defined, XOR and XNOR, and in the other 4, they're not. In these 4, the meanings become entangled. I just want to look at the truth tables, the 6 truth tables, just to get this across. I've quite deliberately placed all the symbols in a common place, so we can see the only bits that by which the truth tables differ. If we look at the bottom at the XOR and XNOR gate, you can see that consistently in XOR gate, minus in this case represents the same, and plus represents different. And that's you see that the third and fourth columns. This confirms that 2 things are the same, give you minus, and on the other hand, the first and second columns, 2 things that are distinct, give you plus. And in XNOR, it's the mirror opposite. In the other 4, you notice that that meaning doesn't apply to each of the symbols anymore. In fact, you look at an OR gate, you've got minus, 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 and plus, plus giving plus. Well, the symbols, the meanings have been scrambled. AND gate, NAND gate, and NOR gate, it's the same. It turns out if you simply do like I've suggested with the XOR and XNOR gate and put one on top of the other, if you do this for those 2, and then you just slide the 2 remaining columns relative to one another, you can generate all the logic gates. But when you're doing that, you are mixing up the meanings of the symbols. And I think that I haven't really dive deeply into that yet, but I can see that I can see the footprint of order 4 in this, which you'd expect because you've got 4 possible inputs and 4 possible outputs, and they can only be arranged so many different ways. I just want to digress a bit here because again, just an observation with the what I call the powers of the 6 powers of the cube root of -1. But by that I just mean if you take a root of cube root of -1 and then multiply and then take the first power, second power, third power, fourth power, fifth power, sixth power, you'll go through 4 complex numbers and 2 real numbers. So you've got 2 real numbers, which it's kind of analogous situation where the symbols, the meanings are clearly distinct and separated, and the complex numbers where meanings are mixed up, just like AND/OR, NAND, and NOR, as opposed to XOR and XNOR. And so I'm just observing here there is the same pattern. So the sign multiplication rules for the real and imaginary numbers are related to the truth tables for XOR and XNOR. But the real and imaginary numbers are constructed so they can be manipulated using equations which work in XOR only. And as a result, they're not treated symmetrically. So let's just look here. The privileging of XOR over XNOR in the construction of the mathematics enables complex numbers to be represented in an Argand diagram, which has perpendicular real and imaginary number lines crossing at 1 common 0, which is the imagined point at which +1 and -1 mutually negate, i.e. 1 and 1 are the same. So the difference between them is nothing. And where +i and -i mutually negate, i.e. where I is the same as I, and so the difference between them is nothing. Nevertheless, I think I can see the footprint of the symmetry group of order 4, and I've just put it's like a Necker cube effect to show that there is where you can see this pattern emerging. You can see that in you can see the sort of face of a cube emerging. And that on the right is treating XO and X0 symmetrically, giving them equal, if you like, priority. Whereas in the traditional construction mathematics, where we use equations, there's 1, 0. So we simplify things. And I think in simplifying things, we're conflating things. So how does counting system model entanglement? Well, you can have a pair of rings rotated by one row each time a count is made, but you can imagine that one side of a pair can rotate with the complementary side of another pair. I have this particularly in mind in terms of clearing offers and wants in an economy, where you have something. Some people want to sell something and they need to buy something, but basically what you're doing is you're saying, as long as I'm conserving mirror symmetry, I can rotate these columns in pairs, and so they become out of alignment. And they can misalign, so the meanings of the ones and one underlines are no longer cleanly separated, and they can remain in that state until the other side is rotated with the complementary side pair on the other side. And again, there are 6 possible combinations, 2 in which the meanings of 1 and 1 prime are underlined are cleanly separated, and 4 in which they're mixed up. And this is a system I devised to clear offers and wants in an economy without using money. But I've not really dealt with that in this talk. It takes another talk in its own right. So there are actually many, I think, potential applications that could exploit this, what I call the entanglement. One is the still chemical instance of wants inherent in barter, which is an alternative to using a counting system known as credit and debt or money to clear distinctions between offers and wants, using an order 4 instead of order 2. Another, I think, could be in the control of movement in 3D, coordination of movement on the left and right side of the body, where I think I can imagine couplings of muscle antagonist pairs, for example, or their equivalents in robotics. Another might be cryptography. There are plenty more possibilities. And just at the end, I'd just like to make an observation, because I read in Caravelli's book, The Order of Time, because this really went deeply home to me. So Ravelli is suggesting that increasing entropy correlates with the loss of distinctions between objects viewed with respect to their original arrangement. Past and future would become indistinguishable if the number of distinctions is conserved. At the time, I was thinking, well, I've got, with offers and wants in an economy. When you've cleared the distinction so that what people are offering is actually what they want, so they don't want to sell and buy anything anymore, then kind of you've had a loss of distinction between objects with respect to their original arrangement. You've had an increase in entropy in an economy, and then the economy is going to shut down without some way of bringing the entropy down again. So mutual negation of +1 and -1 affords 0 to afford 0 results in a loss of a distinction, but mutual negation of +1 and -1 to afford +0 and -0 would not. So you would conserve distinctions. I just think something has to do with time and the order of time. Obviously, entropy is the concept from which we understand time going forwards and backwards. So that's the end of my presentation. The front page of my website tries to summarize what I've attempted to convey in this presentation and offers ideas for potential applications. It probably needs a bit of updating because I've updated the ideas not gone through, but there's lots and lots of ideas about representative colors, black and white, and all sorts of things. So thank you for listening. And there's a page for contacting me by email on Caracan website, or I can be contacted by ResearchGate. And I'd now like to sort of open up for any questions.
Oh, excellent presentation. Thank you.
Thank you very much, Martin.
Yeah.
Let me just stop sharing and bring you all back on. There we go.
Thank you. Yeah.
So yeah.
You want to go first, Christopher, or should I?
What do you think? I don't mind. I usually go first, I think. So maybe you want.
I may have a couple, then I will give to you.
Okay. Yeah. Great.
Okay. I'll give you a couple, and then Okay. One of the questions I think is I was thinking about, they're not in order I'm saying, but entropy. I was thinking about entropy you mentioned. I think that's interesting because I was quite, the thermodynamics was one of my major subjects. Now, physical metallurgy, and then now I'm physics, that we talked about. But the question I have, entropy, I think if I remember it correctly, you mentioned about the distinct loss of distinction, right?
Yes.
Between past. So, like a disorder, order brings out distinction. The disorder brings out loss of distinction. That makes
Yes.
sense because entropy is essentially that. The second law of thermodynamics says
Yes.
entropy keeps increasing. And
Yes.
Sabina Hassenfield is refuting that actually that may not be completely correct, the second law. But in any case, that's an interesting thing. I think something we can use that, you mentioned +0 and -0 to make the distinction. And this is used in calculus. For example, if you have singularity or at 0, there is a singularity or like a Dirac function, then you approach 0 from right to left, that's 0
Yes.
plus, left to right is 0 minus. So that way
Yes.
you can figure out the actual what's happening at there. I think Riemann probably uses that, I'm not sure, but many other second level calculus, little advanced calculus uses that. So I am, I thoroughly thought about that. I think, that makes sense to, you can apply to calculus also, because calculus has inherent problems. So, that's one of the things I am addressing. So I'm using only like a Jacobian, which is first order. When you go to second order, like what they use in Schrodinger equation or even Einstein equation, this problem of singularity comes, and that's the biggest problem, I think. And so I'm circumventing that using algebra. I think your logic and this thing probably will be applying to that, I think, to solve the problem of calculus. I think that's another area that a calculus has brought about. And there are things like dislocations, things like that, that eventually we may go into the material science. You may know about that. And your chemistry, of course, organic chemistry, things like I when I talk about tetrahedron and the chirality, I talk about the your organic chemistry you can apply. I think it's an application there. So yeah, I agree that you have a lot of application, and only the XOR, you have the 6 of them. I find the NOR and XNOR or something, OR and NOR have the same, the green arrows which
Mirror
talks about
opposite.
distinction.
Yes.
Yeah, they have the same, and here also they have the same on that one. So you were saying only XOR and XNOR has the clear distinction or something like that, right?
Yes. I'm saying that I'm saying that distinctions are conserved, and I'm saying that when you draw distinctions, you look at two objects, and to draw a distinction, you can use XOR comparing object 1 with object 2, and XNOR when you're comparing object 2 with object 1. And hence, and in doing this, you're actually you're counting them in a sense. You're clearing the distinction between them and creating 2 more distinctions. But if you do this recursively, then you will end up with a table because there are only 6, and it just maps to the 6 faces of a cube or order 4, the generators for order 4. Okay. So it's but the fundamental thing is, if you give equal weight in constructing a meaning system to XOR and XNOR, then you can't work with equations anymore. You have to work in duals. I think you get the same sort of results, but you're now working much more symmetrically. And I think for humans, for human society, I think this is incredibly important, because I think the maths we're using now, basically, if you want to solve the double coincidence of one problem inherent in barter, basically banks will create money and debt, and the person buying things will get the debt, and the person selling them will get the credit. But then you can clear, I remember the distinction between debt and nothing and credit and nothing independently. So there's no control of the system. All you can do is pressure the debtor to pay off their debt. But if the person who sold the thing sits on their dollars or their pounds and refuses to buy anything from anyone, then the poor people who are in the debt have to keep lowering their price for their services and their goods until the other person parts of the money. It's unfair. It's actually that will result in inequality. It's inherent in the maths. Nothing to do with politics. It's in the maths. The other area that in sort of in the human world is, but it probably will apply in decision making generally, is in voting. Once you can see that you can look at things in two different ways, two different logics at the same time, you can have voting. Let's say in the States, we're always picking, Democrat or Republican. UK, it looks like it's going to be Labour or Tory or whatever. But the way we vote is we vote for who we like, and then we process the results of the votes using XOR, and we find out who got the most, who got the majority. And in many countries, we end up giving power to people who get just over 40% of the vote, and they get absolute power. But the maths will not allow us to separately look and see who do we reject. And if you can use both at once, then you can find out if, in fact, more than 50% of people reject the candidate that got the 40-odd% of the vote. So you can look from both sides. It's almost like you could start to look at people's likes and dislikes in 3D. So I can see there are applications of this, that not just in the concepts in the standard model and in physics and pure maths, but in the human world. I think that this way we're drawing distinctions in all our belief systems, and human society, is causing inequality between people. It's causing us to elect governments that we didn't really want, because there weren't the proper control checks in the maths. I also think it's causing us to mess the planet up because of the way we use this ordered pair system to believe in imaginary stores of value, which nature doesn't work. Nature doesn't see things in terms of buyers and sellers and providers and customers. It doesn't. It prioritizes. It's symmetric. It doesn't see a meaning. Anyway, so I've gone on, rambled a bit there, but so the point is, I see applications of this anthropological, if you like, or human social, as well as in physics and mathematics, just the pure idea. I think there's lots of ideas. I think you can use this in dispute resolution by looking at two sides of a problem, where people have a big dispute over a border, and you try and redefine what that border is as actually two things, using the two logics. There's lots of different ways you can come into this, and so my website seeks to explore some of these. Anyhow, more questions.
Yeah. So just to clarify this, and then I will have the brief second question. But clarify that, I think it's an interesting thing you mentioned. I think another one is the human resources. I mean, I'm just pointing out right now. I'll go over the video again, this video, and then I may have some more questions, but only about the human resources. What happens is when you select people, you reject as a person, right? But a lot of times your table will look at the person who is rejected. I went through these things, and that's why we are created this. And then our channel, for example, our YouTube, the particular text now actually uses the people, like many of us were rejected by the system in some ways, bureaucratic system. But now I think this one helps to look at that and then promote us, and then people start seeing why, that we have a unique original system which many people are not able to accept or able to really able to assimilate. But now, but because we are going through clarification process, I think we will eventually be able to clarify that. I think it's a communication problem partly. I found that people, it's too complex, people put them off, and it's a natural human reaction that the systems. So we have to kind of break it up, we have to kind of decode, and also what you call dissect each part, and then see how that's what I'm thinking now, that what people now understand versus what the new thing is. Dissect each part and then clarify each system, because people are not really understanding. Like Christopher has a very nice way of total objective evaluation of my formalism, and we went through last time that a lot of it is not what he puts as a person, the shoe of a general person who understands it, and that's a fantastic way. And I am also like to do that. Is that he said many people may not understand what I have talked about, and then I presented some conference. Some people have asked the questions, but many people may be flabbergasted, I'm sure, because such a new thing. And I think it's maybe very similar yours, but you have probably given a lot more in terms of giving to university. I don't know whether you presented Cambridge University or Oxford or some other nearby colleges, but I think you presented some colleges. So they, as you present more and more, I used to be a professor, adjunct professor, one of the universities, top university called Arizona State University, and then I was at Penn State with Professor Pickering, and you remind me kind of similar. He was my mentor for postdoctoral, and then I had Case Western. I had my PhD, where one of my advisor from Harvard, he was a physicist, and then another one is physical metallurgist. So that he was my main professor, Heman, Professor Trano. So I am, I know exactly, and I attended many conferences and people, seminars, things like that. People presented, and sometimes as a student, I kind of push myself to understand things, but later, I had to admit that, I don't understand all of it, but then I look back again, review it, and then rethink in my own way. I start understanding the deeper aspect. I think your thing comes very similar to me, that aspect, that there's a deeper thing in there. For example, the second question then relates to that, the sheep counting, right? You mentioned that when you count, the distinction loses, becomes zero. So how do you know whether the sheep is there or not? I think that's a problem that probably will be useful in virtual reality or augmented reality, where you are asking the computer to recognize that. I think we apply to that. Okay, so let's look at how that comes. Your thing, you start with a sheep and come to a full circle, then become zero. So how do you know the sheep is there or not? So I will briefly tell that. You may be able to clarify and explain. So that's one of the things we have to do step by step, how exactly that is applying to distinguish the sheep. So I would think that offhand, it's very similar to entropy for me, 0 minus and 0 plus. So when the sheep is there, I would think it gives us, it's a simple way. I didn't analyze the whole thing. You probably could. I would think when the sheep is there, it may give like a 0 plus, and the sheep is not there, it may give 0 minus. That's the simplest way I can think. But you may be able to explain, analyze exactly how it goes through, and they're able to distinguish that there's a sheep or there's not a sheep.
Right. So on that, right. So what I'm suggesting is, where you've got the let's ignore counting for the moment, and let's just say the sheep is a physical object. I'm saying that we distinguish that physical object with respect to what it is not. So actually, it's not that there's just so there's two parts to the distinction. I've identified what the sheep is and what it is not. When I count objects in a set, I count them only once. So when I come, if I'm going through a counting sort of string loop between all the objects, if I come back to a sheep I've already counted, I pass over it. It's already been counted. But what I'm trying to get at is the idea that that which distinguishes the sheep from what it is not is different logically and conceptually from a cleared distinction. That is, where a sheep and what is and is not a sheep has been cleared. So when it's been counted, and I think that those two things are conflated in pretty much all our thinking. I mean, this is, I think, how maths works. It's how our society works. It's how we think.
Is there a problem? Is there a problem with that? What is the problem with that issue, though? All right, so you counted the sheep, so you've cleared it. You know that's a sheep, and then you move on. You count another sheep, and then you come back around and you encounter the same sheep again. You've already cleared it, so you skip over it. And
So the problem is you're privileging XOR as a way of drawing distinctions and assigning meaning over XNOR, which is equally valid. And you're assuming that it's arbitrary. You can pick one and it doesn't matter. And what I'm saying is it absolutely does matter. And you need to work with both in the mirror.
So when you've got the sheep there, you've counted it. Is that what operation in XOR, let's say, is that? It is it's the distinction part, is it? So it's the 1, 0 equals 1. So we count 1. Is it?
So what? Well, you're actually counting 1 and 1 prime. So you're seeing the sheep.
Oh, yeah.
You're counting the sheep, and you might.
Sorry, just to make sure that we know, define everything. The 1 prime, the 1 is the sheep. The 1 prime is everything that is not a sheep, correct? Or not?
Well, no. 1 prime is not the sheep, and the distinction that's defining what we just call as the sheep is a relationship between two things. And what we do, because we only work in XOR in all our thinking, we think of the sheep as the distinct object. And I'm saying a distinct object is defined by an oppositional pair, what sheep is and what it is not. And so when I clear that distinction, so the sheep disappears and the distinction is gone, that clear distinction is something different in kind from what a sheep is not.
But does the sheep disappear, though? Because you've counted it, so it's kind of in a sense it has appeared because it is now within your register of counting, whereas before it wasn't. So
now what we're doing with that counting step is we're saying there are the sheep, the objects, the physical objects, and there are the crossings between them. And we're going to look at the sheep as if, let's say, they're expressed in XOR, and the crossings as if they're in XNOR. And we're going to represent. So we're seeing two things that define the distinction, and then we're going to abstract the physical image of the sheep, what it is and what it isn't. And I got little arrows in the diagram to get the crossings.
Yeah.
And effectively, what we're doing is we're closing the distinction between what the sheep is and isn't, which actually means two symbols, not one. The little arrows, the spaces, and not. And then we're opening up a new distinction between the ones and the one underlines. And I'm
okay,
using...
does that answer the question about whether sheep disappears or not? Well, also it kind of brings up a new question, which is, or you didn't really display that in your talk, how like counting the sheep is XOR and the crossings are XNOR. It sounds interesting, but like I didn't initially get that from your slideshow.
Right.
I might have been more. I might have understood the later parts, because I did get a bit confused in some of the more complicated things about rings, and that bit I didn't follow. But
right, so
talk about what I do understand first.
Yes,
there does seem to be a couple of things that I'm not sure about. I don't know what you think, Rajan, but because so let's say at the start we're using just zeros and ones in the XOR. So and you mentioned, so we'll start with that. And 0 means the same, but 1 means distinct. But that would mean that you're looking at 0, 0. So you're saying same equals same. But then you have distinct and same equals distinct, which I would have thought that would not be how you would approach XOR, how to think of it, because it seems to be almost doubly abstract. You're not just saying count 1 and nothing, and then you get 1. You're saying that each symbol is like a pair of things. It's like 1 means you have 2 objects, they're the same. 0 means you have 2 objects, they're not the same. And so then you have same, not the same equals same. And that I find confusing. So have I misunderstood you there, or?
Yes, I think you may have.
Okay.
So we count objects that are distinct, not those that are the same. With XOR and XNOR, we use the same symbols to have opposite meanings. We assign opposite meanings to the same symbols.
So when you say we count objects that are the same, you mean objects that are the same category, let's say, like we're counting sheep, but we don't count the same sheep multiple times.
No, each sheep gets counted once, but it's a dual because you have one count in XOR and one in XNOR.
Is this the idea of the mirror image of the coin?
Yes. Here's another way to get this across. Right. So if 1 means distinct and 0 means the same, when 1 interacts with 1, you get 0. What does the 0 mean? Well, then 0 interacts with 0. What do you get? And again, you get 0.
You've already said 0. The other one is distinct. So you're saying same.
I'm saying so when 0 interacts with 1, you get distinct. But then when distinct acts with distinct, you get same.
So could you give us an example of that in the real world, like sheep and a different sheep? Same sheep?
So it appears that the physical world is very mathematical and you can count objects.
Yes.
Yeah. So and the order in which you count them doesn't matter.
Okay.
It's 1, 2, 3, 4, 5, but you can count them in any order. So any permutation of orders, 24 factorial for 4 objects. If you count them in a ring, you can count the crossings between them, bearing in mind that the concept of a sheep is an abstract, I suppose, it's a physical thing. You can detect you probably count the number of bleats or something. There's some physical property that you're relying on, and something, and an absence in between. But you could count the absences instead of the presences.
Well, yeah, I see what you mean. Like the absences between the sheeps or something.
Yes, but it isn't.
And as long as it's in a ring, you'll have the right number. Because if it was just a line, then you wouldn't. You'd wind up with only 3 intervals for 4 sheep instead of 4 sheep.
That's it. So in a ring, you will have 4 crossings between the sheep. It's like the sheep are sort of in a field. The field's a sea, and at the moment we tend to conceptualize the field as nothing, and that background of nothing applies to all the sheep equally. Just like in the Argand diagram, the 0 between +1 and -1 on the number line is the same 0 as that between -i and +i on the number line.
Right.
Because we're using the same logic of XOR only. So although we're working in imaginary numbers, when we're comparing I with I, we say it's the same nothing as when we compare 1 with 1. What I'm suggesting is when you've counted an object, because you can only count it once, effectively conceptually you're clearing the distinction of that object. I mean, obviously physically it remains again, because you can count things any number of times, any number of ways. Physically the sheep remains, but conceptually what you're doing is clearing the distinction that defined that one sheep, and you're coding that information now into a new distinction, which is, it can be between 1 and 0, or I'm doing between 1 and 1 underline. But I'm saying that the distinction that you started with the sheep is actually the sheep compared with not sheep. What the distinction is that between what the sheep is and what the sheep is not, which is physical property. And then with the numbers, it's the meaning of the same and different. You're creating another distinction. As you count the sheep, each sheep as you count it, you clear the distinction, which is the perception of the sheep, and you're now creating a new perception, which is the creation of the number. And the number, the 1, is actually part of a distinction between 1 and 0. And each time you perform an arithmetic process or subtraction together, you're actually moving down when you're closing a distinction and creating another distinction. And it's actually as if you're rotating the cube, you're rotating space, if you like. But the key thing is, when you're using 0 with relation to defining the sheep, the distinction between a sheep and its field, it's different from its apples and pears to the 0 that's between that draws distinction between a distinction that's been cleared and not cleared, or two things that are the same. They are conceptually different, and if you use XNOR and XNOR, you reveal that. Just as in the voting system I've described, you can now draw a distinction between who I'm voting for and who I'm voting against, which conventional maths will not allow you to do.
Right. Yeah, that's interesting. There's a couple of things there. It seems like we're talking about the sheep, and you know, you were counting sheep during your presentation, and we did not fall asleep. So there's that.
Oh yeah, sheep. Yeah, that's a nice thing. Yeah, sheep. You can keep counting for sleep. That's excellent.
Yeah, they keep me awake at night counting sheep. Right,
it will not help for us. That will not help anymore. The counting sheep will not help anymore.
Oh God, what have we done? What have you done? Right. Okay. So
just kidding.
Yeah. This is an interesting thing now, because we have the sheep, and then it seems like, and then we have our abstract counting system, but then you're like slotting an abstract system between the sheep, the counting, and then a further abstract system, and perhaps more in between. So it's like, yeah, it seems quite complicated. But so I'm not sure if I can fully. What I find it's kind of this deep abstraction. It kind of seems more like a spiritual sort of concept that you're talking about. It's a little bit thinking about something like this. So if you don't go too deeply into it, but just on the level that we get from your presentation, it reminds me of like a Zen koan, like sound of one hand clapping. And what people say about those is that they're supposed to like clear your mind and allow space for a new idea to enter. I'm not sure if they do that. What I do think they do more of is more like a rabbit in the headlights. They clear your mind because there's nowhere left for your mind to go because it has reached the end of its logical capacity. So I think that could be something that you're touching upon.
So maybe, but imagine. So here's a distinction. This is a distinction, not this. This is a distinction.
Okay,
and I clear one distinction and I open up another.
Yeah. Well, so I mean, I'm interested in this idea of chirality, because when you talk about a right and a left hand, they are distinct, but they are not necessary. Like chirality, as we know, is not necessarily plus and minus. Like when we put the two hands together, they don't cancel out, whereas 1 and -1 should cancel out, right? So I don't think the analogy there is completely correct. I know when you talk about
yes, it is. It's not, okay. I'm not drawing an analogy. I'm saying the 1 and -1 cancelling out is wrong.
Oh yeah. See, this is where it goes.
Yeah. I'm saying 1 and -1 don't cancel to nothing. They actually, you look, what 1 acts on -1 and -1 acts on +1, and you get 2 nothings.
Right. So, but then
you actually believe in chirality.
Go on there, Rajan.
The chirality is the basis. So you say everything is chiral in a sense that even +1 and -1, in a sense, you have to consider as chiral. So you should not. You should always think of chiral. Even a 0 is like this, but it's actually chiral. That's what you're saying, essentially.
So that's exactly right. So when I started doing this, before I went into the maths, I wrote a little novel called Resolution of Zero. So in organic chemistry, people eventually realized that some organic compounds which have where the carbon is attached to 4 different molecules can exist in 2 different forms in 3D space. And these are called enantiomers, left and right-handed forms. And it turns out that life can discriminate between them. I mean, nearly all the amino acids in your body are L, or one configuration and not the other.
Left.
So this idea that a molecule of one formula is actually 2 different things, can be 2 different things, lies at the heart of this idea that 0 is actually 2 different things, and I've resolved them. I've pulled them apart. One's in XOR and one's in XNOR, and the operations that you perform and the arithmetic that you perform are mirror opposites, chiral opposites.
Okay. I think I was just talking about from a conventional mathematics point of view. 1 and 0, or 1 and -1, and then left and right would be separate, could be separate. But then if you're talking about rotationally, you could have them cancel out to 0. But I mean, in another way to look at it, let's say you're saying -1 + 1 equals, let's say, +0, +1 -1 could equal -0. But then couldn't you go plus the 0 minus the 0 equals +0, and -0 equals +0 equals -0, and then you could just keep going, or does that make sense?
Well, it's recursive. So it is recursive. I mean, it's in order 4. It's the whole thing. So yes, each time you do what will be analogized to a mutual negation. You simply create another distinction, another pair. So yes, that's exactly right. You never lose a distinction.
That kind of reminds me of something Rajan was doing with well, it was slightly different, but it was like a matrix that could like produce a matrix within a matrix, and it just went on forever and ever. A bit like what we saw with
there's Mandelbrot stuff, the fractals. Yeah, I mean this would be fractal in its nature.
Okay, but like okay, then that's fine, concept. But in terms of like reality, then what does it mean to minus a plus from a minus 0 to get a different answer than the other way around? Seems almost completely abstract, like you're stepping into a world of different.
I think the concept of 0 is completely abstract. It just means the difference between two things are the same, but 0 has no physical properties.
Yes. Okay.
It's something you choose to believe in. It's an act of faith. It's a spiritual thing. Belief in nothing is a spiritual thing.
Oh, okay. Yeah.
Believe in it. But
I see what you mean.
You can't prove it's there.
Yeah. So I think though when we get beyond this this initial +1 -1 and its opposite, and then when we start delving into that and plussing and minusing zeros from each other, you're into this sort of upper abstract realm where it doesn't really apply down here on Earth.
It does. No, it really does. On the contrary, I think it's actually how down here does work, and I think it down here does not work in the physical world in XOR alone, because I think the physical world has no meaning.
But I think wouldn't you that XNOR is the foundational working of what's going on down here, because I don't think most people on the street even know what XNOR is or XOR. You know, if you were to just ask the random person, they probably wouldn't have heard of it. Like most of the world.
No, I agree, and that's why it's a very hard idea to swallow. But we've all grown up from childhood being taught that the difference between two things that are the same is nothing.
Yes.
Not just mathematically, but in our whole lives. And people talk about, is there a purpose in life or not? Well, all these things are actually constructed out of oppositional pairs. Every concept we have is constructed out of an oppositional pair. Now, in the social sciences, the French philosopher Derrida tackled this and showed that with texts, written word, you can deconstruct all text. You realize that somewhere in the text there will be some privileging of one term, one concept, and if you can dig that out, you can flip the meaning of the whole text.
Right.
Now, mathematics has resisted deconstruction. So in sort of the postmodernist construction, texts, art criticism, and so on, have all been subject to this deconstruction approach. Mathematics hasn't, and actually the mathematicians as a group, as a profession, or I would regard it as a priesthood like any other, would like to believe that it's okay to just use XOR, to believe in nothing, because mathematics is all constructed out of nothing. All equations are constructed out of nothing.
Of course, right.
The difference between two things that are the same.
Yes.
Foundation.
It's fascinating though how much they can get out of that though. Well, all the rules that are involved as well.
Yes, it is. It is, and all the complexity, and it goes way over my head once we get to the higher levels of calculus and so on, and tensors and things. But it is fundamentally all constructed out of nothing. And artificial. I asked the ChatGPT one time, what's the principle on which you work, and it said equivalence. In other words, when two things are the same, then the difference is nothing.
I don't know. I think ChatGPT works from you know, it's statistical. It just picks a word and then it chooses what's the most likely word to come out.
It's a bit random, but conceptually,
well, it's probably stochastic, but it's not entirely random, because if it was totally random, it would just be like an infinite monkey thing. It would just type nonsense. But
yeah, no, I agree with that.
But the ChatGPT, you know, like they brainwashed ChatGPT so that you just don't trust anything it says. It's garbage.
I know that, but the that said, I think you'll find that anything that's constructed by humans is presently coded only in XOR, in the sense that it's founded on the belief that the difference between two things that are the same is one thing, which is nothing. And so I'm saying when you make that, you're doing a reduction, and it must always be two things, one viewed from with respect to each of the two things relative to the other. And if you do that, you conserve distinctions. You conserve the number of distinctions in your system. If you don't do that, you lose distinctions.
Okay, yeah. I'll go with that as a concept. Yeah, I think that was the first time you explained it, that it kind of, you know, that yeah. So, sorry, Rajan, I've been talking a lot. Did you go ahead?
No, yeah. I only couple of things, and then I'll again go back to you. What Christopher mentioned is very, very accurate observation. Like, I mean, Martin, you remind me of my Professor Pickering, mentor to some degree. He was also English, England originally, his forefathers. But two things. One of them is, I think, you know, you can apply directly to like neutrons. So each ship may be like a neutron. And so what I think is that the other ship is like an exact copy of one of the other ship. You know, it looks exactly the same. So they cancel out. So if correct me if I'm wrong, I think what you are saying is that you count the ship, and the crossing is you go from one ship to the other. Is that right? The crossing is like ship one to ship two is the crossing. Is that the crossing?
So it would be, well, you can either count sheep 1, sheep 2, and sheep 3, or sheep 4, or you can count crossing 1, crossing 2, crossing 3, and crossing 4. But I'm saying,
what is crossing? I don't understand that crossing. What exactly you mean by crossing?
Well, you would by analogy by thinking of one of real and imaginary numbers, but I'm saying that there are the sheep. What we think of as the sheep as a distinct object is defined by a relationship between what the sheep is and what the sheep is not, and that requires two symbols.
Yeah, I agree.
To define it, and so by analogy, it's one and I or something. But I'm saying if you use, let's say, XOR notionally as represent to define your sheep, and XNOR to define the crossing, what it is not. XOR is what it is. XNOR is what it is not. Then each time you count or you perform an arithmetic operation like a negation, and you take an object from one category to another, in the case of here it be from the physical sheet, what is not, into the abstract, which is 1 and 0, 1 and 1 underline. You always have two objects of the sheep, what the sheep is, what the sheep is not. You've counted that one sheep, but what you've ended up with, still two sides of a distinction. And each time, if we perform a negation with that in a subsequent operation, we do that, and it becomes like that. Because you're using both XOR and XNOR all the time, which are mutually exclusive, you cannot simplify it down to one thing. There will always be two.
Okay. So just to clarify, if you know, I want to simplify this in a a simple way. I'm sorry. So it may look a little bit loose, but one of the things I understand is that each time you count a sheep, for example, the XOR says is 1. The XNOR will say negative, one underline. Okay, is that right? So both of them will count. Both of them will record. It's like a counter. You have XOR as a counter and the XNOR as a counter. So both of them will be active. So when it sees a sheep, the XOR will say 1 and the XNOR will say underline 1. Is that right? So both of them will record simultaneously.
So actually, so what I'm saying is that you are dealing with a quaternion, a unitary transformation. You have a quaternion, and you have two mirror opposite quaternions, just as you have the rows in the truth tables for your inputs and outputs. So the distinction, let's say, that distinguishes the sheep from what the sheep is, what is not, is represented by the arrays of 4 numbers on each side, the mirror opposite. Okay, it might be one underline, one underline on one side, and then the mirror opposite on the other. And then when you count the sheep, effectively what you're doing is clearing a distinction by swapping a 1 and a 1 underline in the top row.
That's why I don't understand.
The top row, and then you're coming down. You've cleared a distinction, but you've created another one. In moving the 1s and 1 underlines, you created a new distinction.
So
each time you count again, there's a new distinction.
Yeah, let me clarify, or I want to clarify this a little bit, because I think this is fundamental. I think fundamental logic. I mean, I'm trying to understand it. Sorry, I didn't understand completely. But suppose there is a sheep. Okay, the XOR will say 1, right? Is that right? If there is no sheep, the XOR will say 0. Is that right?
I'm saying if there is a sheep, let's say on one side, if you're taking this into the counting system, the presence of the sheep might be 1 underline, 1 underline. And what the sheep is not might be 1 underline, 1 underline, 1. It's not as simple as
XOR will say. The XOR will say 1 and 1 underline if the sheep is there. Is that right?
No.
No.
It is a quaternion acting as a unitary number.
So suppose, like, say, we have XOR counter, right? Just XOR counter, and then you have a table. The counter, the table, suppose it sees a sheep, it record. Does it record just 1 or 1 0 or 1 underline 1? You know, that's what I want to clarify.
Right. So recall the table with or recall XOR and XNOR one on top of the other. So you've got 6 rows of 4 columns. And
we have to go through an example.
Contains 2 1s and 2 1 underlines. And on the other side, you have the mirror image of that. So as you count an object and clear a distinction, you exchange in that first row a 1 and a 1 underline. So you go down to the second row, you're forming the second row, where in effect you've exchanged a 1 and a 1 underline, and you do the mirror image on the other side. So the act of
maybe it's a good idea.
Well, I'm following this bit. Just keep going. Just keep going.
Yeah.
To the next point, and then if you lose me, Rajan, just keep going. What's the next line? Because the next line, what are you doing? You're going to swap what?
So let's say we started. Let's say with 1 underline, 1 underline.
No, I've got that. I'm just saying. So keep going.
And then the next line would be 1. Let's swap the rest. So we said 1 underline. So it'd be 1 underline 1 underline 1. So two of the four symbols will have been exchanged, and two will remain the same.
According to this, are you talking about in the XNOR table?
Yes. And then on the other side, you will have the mirror.
Yeah, of course. Yeah.
But then when you do the next step, the next row down, it's actually, if you do X, so the first step was XOR, the next step will be XNOR, and the next step will be XOR, and the mirror opposite will be the other side.
Oh. So actually the first sheep, the XOR will count. The second sheep, the XNOR will count. Is that right?
So that's no. So you would become, so when you count the sheep, you would end up with a number which you might represent as 4 underline 4 underline, because there are 4 of that unit.
That's a hard part. I mean, maybe we'll go to example and just take one sheep and say what XOR will count, what XNOR will count. If you can show that, I think that will help. And then we go progressively, like step by step. How we,
maybe you could use
that will help.
Paint program. If you have
if you don't mind, thank you.
Or type it out.
If you don't mind. I don't know about Christopher. I thought that would clarify a lot of things.
Yeah, that would clarify. No, I thought I was getting there, but then I couldn't understand how the next row came about.
Yeah.
And
so we'll go step by step. Use one sheep and then like that. Just take one sheep and see how the XOR will count, how the XNOR will count, and that how does that help with having a sheep and not having a sheep.
Right. Okay.
You know what I mean? So, that just go to the most fundamental level.
So the most fundamental
level, if you don't mind,
you are working. The most fundamental level, you are working in a pair of quaternions. At the most fundamental level, these are unitary quaternions. They transform as a whole. They're unitary quaternions. They're like a left and right-handed molecule. Okay. So if I've got 2 fingers up, 2 fingers down, I'm going to struggle to do this. So those are the 4, and then when I count, so I count, it'll be that one exchanges, say, with that one, and each time you count, not the sheep in the row, but each time the sheep, if you like, move from one field to another and they're counted again, you move one row further down. So
okay, so wait a second. So you're saying that there's a field with sheep in it, and then there's another field, maybe with some sheep in it or no sheep in it. And when one sheep moves from here to here, and then you count the number of sheep in this field, one of them maybe moves, and then you count again, and then you count the number of sheep in here, and so the system is keeping tabs on how many sheep are in each field or something like it. It's a higher level.
It's accounting. It's a form of accounting because what I'm saying is you can count the sheep, and you will code that or process that information as an array, a quaternion of 2 1s and 2 1 underlines. But then, having done that, let's say you've got 4 sheep you've counted, so it'll be 4 times 1 underline, 1 underline, and you can put 4 on each.
Okay, but would the number change then?
Yeah, but then if you want to perform the arithmetic operation,
order of the 1s and the 1 underlines, or you would. Does it
so
do that?
So you would use all 4 columns. You'd have a unit in each, and the number of sheep is 4 times all those. And also the same in the mirror.
Okay, but what does the order mean, though, of those particular 1s and 1 underlines, Martin?
So the whole system is governed by the symmetry properties of order 4, and so that's why it maps to the faces of a cube. So when you count the first time, when you clear a distinction and record a new distinction, so you record the count, you simply, it's like you've rotated the cube from one face to another.
Okay.
And and in parallel, you've rotated the mirror image around 1. And then if you perform, let's say, a mathematical operation like subtraction and negation, you do another rotation of both.
Yeah.
Because now we've started to perform arithmetic, not by negation, but by rotations. So we've taken an object from one category and put it in another. We've cleared the distinction in one category, one row, and we've gone down to the next row. Now, why does this work? Well, what's practical, and this might help.
Yeah.
Think about how money and debt work. So
okay.
Let's talk about, but because this might help you get this idea.
Yeah.
This is how I got there. So let's suppose you have a pen that Rajan would like to buy, but he wants to sell something, but it's not what you want.
Oh, yeah,
something you want. So we've got a mismatch with what we're offering and what we want.
Yeah.
So in current maths, which works in XOR only, what we would do is, to solve this conundrum, we would create a plus minus pair, or credit and debt, or money and debt. And let's say, if you wanted to sell your pen to Rajan, he would receive -1. He would be going to debt by 1 unit. Let's say it costs 1, and you, having sold it, would now get +1. You get $1. Okay, and then once we've created that pairing, now you've got money. You can buy something from me, which you want, and I get the money, and you get the object.
Yeah.
And then Rajan can clear his debt by selling something to me.
Sure.
Okay. So this works in double entry bookkeeping, or ordered pairs, numbers, or signed integers. You create from.
Then you're in debt, Martin. So yeah.
So if you've sold your pen to Rajan,
yeah,
then you are now +1. Rajan is now -1, and at the moment I'm on 0, on balance.
Yeah, true.
Yeah. But I've got something you want to buy. You want to buy a Maasai artifact for your pound. So you and I then take the pound or the dollar, and you're now back in balance. You've gone from 0, 1,
and so
and
so are you.
1, 0, and cancelled. Your ones now become 1, 1, which is under XOR is nothing. Yeah.
Okay.
And now I've got
so
0, 1.
How would your system do it differently then?
Right. So the key thing to note is you can go back to balance by buying something from me for your dollar.
Yes.
And independently, Rajan can go back to balance by selling something to someone else and go back to balance that way. Okay. These are independent. So the two of you, to initiate the cycle of exchange for the pen, the two of you create +1 and -1.
Assuming that Rajan wants to go back to balance, because in general people don't want to go back to balance.
Well, now you're getting to exactly why the maths of what I'm saying is really important potentially.
Okay.
Because this mathematics that I'm describing will oblige the two of you to go back into balance.
Okay.
Both of you.
Try that then.
Right, because we will say the first step, you're creating a distinction.
Got it.
Yeah. Now you have to then, which you're creating this. So originally you two of you are related XOR to XNOR. Now we've created a distinction between you. We've entangled you.
Okay.
The next phase is you are able to sell something hang on, you've sold your pen. So you buy something from me.
Okay.
Yeah, but that hasn't cleared the original problem, which was that Rajan still has the minus. And what I'm saying is, he then can have a transaction with someone else, and only when both of you have done your mirror opposite buyings and sellings can you rotate through to where you close your deal at the deal completely. So the maths is controlling from both sides. Credit and debt, plus and minus and equations, are used to manage the system, but it manages it from one side only. And actually, it puts all the pressure on Rajan to pay off his debts. You're under an obligation to spend the money you've earned. You might not want to, you'll sit on it.
Yeah.
But this maths, because it's working in the dual logic, we can control the system so we don't close out between the two of you until each of you has both bought and sold something.
Oh, yeah.
There is an extra step involved.
Yeah.
So let me clarify another one. So Christopher gets, like, from Cottonian, get 8, like 4 in XOR and 4 in XNOR, right? 4 recording in the XOR, like 1, -1, and all that. So you get 4 in the XOR and 4 in the XNOR to record his transaction. Is that right? So you get 8 of them. So you get 8. 4
so
and 4.
Would be in arrays of 8. So you will have an array for what you
Each
selling,
person will have 8.
what you're buying, and you would clear offers and wants by cycling through the 6 states until each of you has exchanged with everyone else in balance. You both bought and sold to the same value, and at that point it closes.
So like 8 times 3, it'll be 24.
Conventional mathematics allows one of you to close and not the other.
So 8 for each person, which means 8 times 3, there'll be 24 entries altogether, separated.
Well, that's a permutation of a tetrahedron. That's a symmetry group. That's the symmetry of that's the possible. 24 is the possible ways of representing a chiral tetrahedron.
Yeah.
And that's why it's 24. You've got 24. It. It's why it's 24.
So I think I get some part of it. What you're talking about, I think I'm clarify. I think I'm getting correct. So the 8. So like Christopher has 8 of them, and so XOR. So that talks about the 2 of them talk about buying. The other 2 will talk about selling. In XOR, let's say XOR. The XOR, 2 of them will talk about buying. So, and then 2 of them will talk about selling. And the same way, XNOR also does the mirror opposite of that, records that. So then it, so I can conceptually see how it can record that conceptually, but you have to work it out to see exactly how it works. But I think I can understand that.
I would like to just, could I make a point here quickly about, was there not another system that you spoke of either in a paper you wrote or on the website, and it was like, was it how it worked before money, but it also wasn't that. It was like, how would it work before money? Whatever Rajan had, let's say it's that remote sitting next to him, and I have the pen, and they're worth about the same or something, or I think it might have been. So then we'd exchange those, and then you might want the remote, and I want the. Oh, that was it. I don't want the pen, or I don't want the remote, but you do, and I want like what you have, which was an artifact, Maasai artifact. So then we all just exchange. We have a cycle. I haven't met you though yet. So then I take the remote, and then I'm like, well, and then I do meet you, and I go, well, I have this remote, and you're like, well, I prefer pen actually.
Three different objects. Yeah, that makes sense.
It's what. So
The barter system.
the signed integers and the concept equations, I think, evolved as a system for handling commerce originally, and then it got applied and picked up and used in physics and abstract mathematics later. But the concepts of a balance,
but
plus minus, came from commerce. Prior to
correct then, or did I didn't reflect the system there, did I? Or is that system also broken? The one, well, it obviously is broken. The one I just laid out.
I think the system is broken, and I think this mathematics.
But the one I just outlined is broken as well, because I could take the remote thinking that you want it, but then you would have preferred the pen or something. So that's the system wouldn't work.
So there's always the possibility that what people want changes through life, or often moment to moment.
People always want money, don't they?
Well, they do, but that's only because we've led ourselves to believe that it's an asset. Well,
not even that, but I mean, it's just general, isn't it? Like, because it's a symbol, it can stand for anything. So, if I have €10, that's equivalent to anything that's worth €10. So it's like, it's very good. Whereas if I have 10 pens,
you have your choice.
Yeah. So that makes sense.
But you get more taste with money.
Yeah, I mean, it's a general system, which is kind of what maths is based on. But your system is not. It's not using the money. So it's leaving the money out. So we're just with the assets.
You only work with assets, yes.
Yeah, but we have a problem.
Real things you would exchange, but the key is you're always controlling, so as you're conserving distinctions. The current.
I don't know if that's necessarily that relevant though to the barter system, conserving distinctions. I think that would be a bit abstract for, like, if we went to most barter societies and started talking about this subject, I think they'd be just as lost as I am. But I think maybe, sorry, this would be probably one of my last points on to do with the political issue. I thought that was interesting because you mentioned, so let's say a party gets 40% of the vote, which is the majority, and the other parties get like lesser amounts. But then you notice that, well, it's still more than 50% didn't want that party in, but they get in.
You can't tell that. You can't tell what from just using XOR. You can't tell whether or not the 60% that didn't vote for the winning party actually were opposed to them or not. You can't.
Oh, they didn't vote at all. They didn't even vote for a different party.
Well, that also fits in with the system I'm proposing, because now.
Well, if they didn't vote, does that mean? I mean, they're not in this system. So we usually say, if your vote's not,
they've abstained.
Or you could literally spoil your vote as a kind of protest.
So
maybe you don't like any.
So there, you've again coming back to XOR and the system with a balance.
Yeah. Well,
abstention and active abstention are both equivalent 0. 1, 1 and 0, 0 are equivalent to being ineffective in the vote. There's no distinction drawn between 1, 1 and 0, 0. But if instead
what do they represent
and explore,
what do they represent? What does 1, 1 and 0, 0 represent in the voting system? Does 1, 1 represent I voted for the party that won, and 0, 0 means that I didn't? Or what does it mean?
Right. So if we're talking about voting now, using the same construct with these 6 states. So now,
you only have like 4. It's just 1, 2, 3, 4. So if we're talking about XOR.
So let's suppose you have a list of candidates, and first of all, you look at them from the perspective of which do I like the best of this list.
Yeah.
Okay. So I might put a first mark by the candidate I like the best.
Sure.
But now you can say, you can ask yourself a question, do I want that candidate to have power? Do I want to abstain passively and let other people decide?
Yeah.
Or do I want to abstain actively because I want a different candidate than any on the list?
Yeah.
Okay.
Yes.
So two forms of abstention now distinguished.
Okay.
And then on the other side, I can look and say, which candidate do I reject the most?
Right.
I dislike the most.
Yes.
And then do I want to reject that candidate wholeheartedly? Yeah. Do I want to passively abstain and let everyone else decide?
Right.
Or do I actually want to say, well, actually, I don't want to reject that candidate should be included. I'm blocking the, if you like, the rejection of the candidate. So now you've got 6 states. And when you actually run this with people, and I've done this with schools and you get quite nuanced pictures, and you find, let's say you do it for products like the Apple phone and phones, mobile phones. When I've done this with people and asked them to give their views on essentially which phone they like the most and which they don't dislike the most, you find that Apple score very high on the like side and very low on the dislike side, which means they've got everything. They've got the optimal product, because although the people really like them, they also they don't reject them. It's all good. If you just do a consumer survey from the XOR side only, just looking at it from one side, you'll see which is the favorite, but you can't see which things people dislike. And same with voting. If you just do XOR, it's just because you're only voting for someone, and then you use negation as in XOR just to negate one vote for one against the vote for the others. What you end up with sometimes is the party that gets power may actually turn out to be opposed by everyone, or perhaps also the choices you've been given, you didn't have the option to reject both choices. And we've had that situation, for example, in the UK recently with Brexit vote.
Mm.
And you did not have the option to reject the referendum.
Yes.
Passive and active abstention gave you the same output. Now I ran when we had the Brexit, I ran a small.
But so why would that be important though? Actually, because I'm kind of getting you now. I see what you mean. There's a term for that. I might think of it later. But so you let's say you don't want Brexit, so you vote no, and someone does want Brexit, so they vote yes, and then the other option is you don't want the referendum. Yes. Which means
can't reject the referendum.
But if you don't want the referendum, then you don't want it because it's asking you whether to change what's already established. So then you're just voting no. But if you do want the referendum, you are.
Now you're getting to the point about distinctions and the difference.
No. I'm just saying the only reason you would not want the referendum to happen is because you are against having the people having a choice. So you say, which is the same as saying that you just don't want people to vote on this subject because you want to keep things the way they are, which is to vote no on Brexit.
But keep things the way they are could mean it's still an open question. Now, perhaps another. This example might help. Supposing your kid's in a classroom, and the teacher says, "I want you to vote whether we should paint the walls pink or blue."
Okay, but why can't we just stick with the Brexit? That was an analogy already. We don't need another analogy to explain an analogy. So let's just stick with the Brexit thing and say, we can vote yes, we can vote no, or we can vote not to have the referendum. Okay, fair point, but that's basically just voting no. You know. Well, then it would be the same. So then the people who want to vote to have, like, it's just a waste of time, isn't it? Because then someone says, "Oh, okay, yeah, you could," but then it's a different issue, isn't it? Whether then you could vote to have a vote, you know. So that would just be annoying. Like, who's time for?
So no, you are homing in on something that's very important. I need to communicate this to you. So if your perception of a situation is colored by a particular way you're drawing a distinction, and actually the interesting stuff is all happening on the boundary between those, the members are making that oppositional pair, and you want to make decisions based on that boundary, then you want to be able to reject the distinction that's presented to you because you want to see the world in a different way.
Why?
So it does matter.
Why would you want to do that? Like, just with the case of the Brexit issue, the distinction is stay or leave, yeah? And then you want to reject the distinction stay or leave, which would mean what? It would mean stay. That's all it would mean, right?
No.
What? Why not? Because it would mean that if Britain's in the UK or if Britain is in the EU, yeah, and then you have a chance to decide whether to stay or leave, and you reject that, then Britain is still in the EU, and that is the outcome that you've arrived at. So, yeah, I don't know.
No, because you haven't made a decision on that question. It is still open. It is still open for debate. What's happened now? It's not open
for debate because you've just.
What's happened now is
whether it should be open and then close that debate.
No, what's happened is the whole Europe has now broken up based on how actually a very small part of the population of Europe drew a distinction, and now that's a sort of final view because it's happened. But up to the point when that referendum was made, the options could have existed to draw a different distinction and then have a division or a vote that looked at the whole thing in a different way. And you might have found that it went 60-40 or 70-30 or whatever.
What is the different way, though? You have to be specific, otherwise. The different way is like whether we should have the vote on the subject or not, which means like whether we should have democracy or not. But let's use democracy to decide whether we should have democracy or not. I mean, it just I don't know.
So at present in the UK, power flip-flops between two political parties.
Yeah,
as it does in the United States. So it's Labour, Conservative. They're going to flip-flop.
Okay, yeah.
Flip-flop. And
then the same party. That's
You cannot break.
You have a choice.
You're only given two choices.
Yeah, but they are the same choice because I mean, Trump is doing the exact same thing Biden's doing, and so it's great.
Independence.
Yeah. You cannot reject both.
Yeah, you can. You can just. Oh yeah, I see what you mean. Where's the vote to?
Distinction.
I think you can vote an independent.
The
right?
distinction. Yeah, independent.
You can vote for an independent, but you can't vote against.
You'll be throwing your vote away, which is the same as not voting, which is what a lot of people do. So.
Which is what happened.
Yeah.
For that. Okay, I understand the distinction. Yeah, I think one of the things your abstraction is very similar. I have a very similar thought because like Christopher knows, I believe in abstraction. Actually, I presented in the Canadian McMaster University after my postdoctoral about my model, and I talked. There are like top professors there, and Professor Pickering sent me also there, and they want me, to discuss about the faculty there, because I had original model, and It's accepted. That's in electrochemistry. Now I am doing in physics, but IPC model. So how I came up with the model? No, I had a whole new concept. The idea of observation, abstraction of the observation. So you observe things and abstract, and then you create a model like math, very similar to what you are doing in a different way. So I think I like that idea of abstraction. I can understand the background, the underlying background, and I generally agree with what you're doing. I can understand that because it makes sense. I look at finally, does it make sense or not? That's the final thing that is, that's making the thing. If somebody is saying doesn't make sense, then I will start questioning that. I think I have enough logic to question that. I don't reject anything outright. In general, I am more acceptable.
Yeah, it's probably a good idea not to reject something, especially if you don't understand it. If you understand it and you say this is wrong, then you should reject it.
See, that's the problem with publication. Like you sent to fish review. If they don't understand it, they will reject it. It doesn't make sense. It's because I say if I don't, doesn't mean you are wrong.
You should be able to explain your idea probably within an hour, maybe to 20 minutes even. Well, I think there should be different levels. There's explaining it to a child, and then to a teenager, explain it like I'm 5, explain it like I'm 15, and then for undergrads and then experts, assuming there are any, if it's such a new field, there won't be any experts, obviously. So, but on that level, and if you can't explain it to a 5-year-old, and we all understand it deeper, and if you can't do that within then it should be rejected, I think. And
I think I agree with Martin about rejection.
Then we should totally reject your idea.
Yeah. No. What I'm saying is that like a student, I teach now in schools. I taught I'm one of the few people in the world probably taught kindergarten to PhD level. I have taught in ASU up to PhD people older than me, and now I'm teaching students all the way up to kindergarten. So I study them. So I don't have a long.
That's like the first. That's kindergarten is like the first group of students.
Yeah, first group.
There are no students before kindergarten.
You can test whether what you're talking makes. I won't be talking like this, but whether you are talking makes sense or that's why I check myself. So many of them understand that, and sometimes the 4th graders won't understand. Kindergartners will understand. They are more acceptable. They come to me and then say, "Oh, you are the teacher we are looking for." The 4th graders say, "Oh, what? I don't know what you're talking about." Sometimes it does happen like that. So kindergartners are more acceptable.
Well, who's more accepting? Was it the younger children or the older children were more accepting?
When you talk about from elementary, middle school, and high school, it's kind of mixed. But I would say, in generally, elementary school are more acceptable. In general,
they're more accepting. I mean, they accept your ideas.
Because they want to see very similar to what he's saying.
It's easier to confuse a small child. Like you could tell them Santa Claus is. Well, children hopefully aren't watching this, so.
No. The reason is I can
definitely aren't watching this. They'll be like switch off. Anyway, but you know what I'm saying? You could talk to a child in a certain way and be like, "Oh, what if it was this way?" No. They go like, "Oh yeah, that's cool. I like that idea."
I'm talking about math. I'm talking
about like, well, yeah, you'd have to explain that a bit more. And
No.
You very well might be making a good point, which they probably already heard in a different way previously. But if you're saying that what you're saying is entirely new and that it's going to help people, then that's pretty cool. But it does need to do that, and it needs to make sense. Else, it's not going to help people. It's just going to drive them mad.
What Martin is showing, like I said initially, it's a communication problem. So when I go to kindergarten, I know that I have to be clear in each point, right? So they like that. For example, I say use 1 + 1 = 2. Many people will say, just remember that, remember the table. But I explain why 1 + 1 = 2. I explain, I go further than that. And they say, I have 2 pencils. I have 1 and 2, and I want to find out. It's very similar to your distinction, whether there is 1 versus there is 2 there. So it's like a code. So I say 1 plus 1 is the. So I explain all those things, all those what you call the minute variations. I explain, and they said, "Oh, that makes sense to us now." You see
what
that?
are the minute
But
variations? It's just 1, and then you
no, many different ways of explaining. That's why I call it audio. Now I explain it. Audio, image. I explain to the teachers also.
You're not teaching elementary students audio, video when you're talking about 1 plus 1, are you? I don't think that's
explain each one. Audio, image, video, texting, and communication. Okay. No, audio is say, I don't use anything. I say 1 plus 1 equal to 2. I don't say anything. The image, I write down 1 plus 1. Now, that's the starting point. 1 plus 1 equal to 2.
Okay, well, those are just different ways of communicating the same information.
Socrates
you have to do that. You have to do that.
It's interesting. Socrates said, I read just before he was took his poison, I don't really understand math. I don't even understand when you add 1 to 1, do they both together become 2, or does one of them turn into 2 and the other disappear? You know, it's not immediately, when you really think about it, 1 plus 1 is actually not as simple as it first appears.
I know, but we're talking about teaching elementary students like how to count, and we need to quickly go beyond 1 plus 1 so we can get so we can go further.
We can progress.
That is following.
I know there was Rudolf Steiner, for example, with the Steiner schools. He would start like the first day of school, put a bead on a string. I think it was the children would do that, and they would go, "That's 1," and then the next day, it would come in and put a second bead on, and they would go 2, and then so on and so forth until they learned. After 10 days, they learned to count to 10, and then 20, and they had they could see that there was a sequential number that grew in size, and then they'd abstract that, so it was easy enough to do for them, Steiner skills, but it's still like a simple process of counting, and I learned counting a different way to that. I'm sure you guys did as well.
Yeah.
And we still learned it. Like, it wasn't that, because we're so young, it's like, okay, there's some difficulties with registers, but it's not that hard. In fact, it's pretty easy stuff, and you could probably teach them a lot of your stuff. Fundamentals of 1 plus 1, like, for too long would probably make them lose interest. Might be okay for people like our age who've like exhausted all opportunities of interest, and so we return to the fundamentals to question the logics there. I suppose Godel did stuff like that, or Gordel, however you want to pronounce his name.
I think.
But I would say that he went insane as well. So did Cantor, and so I would.
No, you brought a very important point, Christopher.
Not a good idea.
I got my head screwed. I ran a business for an international business for a long time, so I knew the ins and outs of it in science and law. But the thing is this: we have adopted a simple system that everyone can understand.
Yeah,
but it's incomplete and it's not working.
Yeah,
I agree with that.
And the manifestations of that.
I would say though that there's difficulty there. I mean, you might be able to convince me otherwise. But so in the States, you have the Republicans and the Democrats, and then you can vote for one or the other, but they're kind of the same party. So so then really, when you vote for one or the other, you're still just voting for the same party. So that's like you're looking for like a third vote where we can not vote for the system at all.
It's like a mafia or cartel type of thing, like mafia or cartel type of thing.
That's what's needed in a democracy.
Okay, but I think that's probably outside of like mathematics, maybe. Well, it's more like game theory, and I think they've already established the game and they're winning. So I don't think you can't definitely here. Let's play the new world. What are you talking about? And then that will be another level of the game. But still, anyway, game theory can be can be mathematical as well, and I think it's really interesting.
Logic.
That's maybe where your focus should be, because I think this whole thing about XOR and XNOR is too complicated to be appropriate. It doesn't seem to apply to all of these areas as you're saying it should. But I think where you'd be more comfortable maybe would be applying game theory to these areas. I don't think you're going to win anything in politics. That area is completely sewn up, and so I wouldn't even bother with that.
Finances as well.
Or finance
is possible.
But here's the thing.
I think it's possible. Can I explain something?
Yeah, go ahead.
So I think it's possible. What Martin is talking is possible. The only thing you have to dilute it, simplify it. That's what I'm trying to do. I think I can understand it. And if you simplify, I think you can apply. The reason I'm saying is that I think it's like you are also bringing in the category. It's like you are stitching in the category theorem, category, theory with the normal thing. I think I also believe in that.
Start, all right, but I mean, you're saying you're saying you understand this, Rajan.
Understand it more now. Not 100% yet. Not 100% yet, but I understand now.
So you don't understand it either, which is
no 60 or 70%. No.
I would have that problem with a lot of your stuff. So obviously I can't say whether you're correct or not, but I would lean towards maybe that you yourself would also suggest that you are you're exploring ideas. Like you don't actually have answers. You're more like,
idea is
this concept, and I'll see where it leads, and it may work or it may not. So you can't say that you are actually right with what you're talking about, because you don't know.
Well, that's what I said at the start of the talk, which is why I said I'm not.
You understand it more each time.
I'm trying to understand it, not to try and persuade you to do it. But here's the thing.
No, well, I was talking to Rajan there about his work, but
I'll explain that.
Would you say that the same thing applies to your work then, Martin? Do you? Would you say that you're finished, like you've come to the end, or you're still working on it? You don't know if what you're saying is correct.
No. The thing is that there are steps, right? So each step you look at that. Okay, I understand 50%. The next time I understand 60%. So you are going the right direction. Suppose you are going the wrong direction, you reject that. I agree with that. That's why I use flow chart, decision tree. I told you last time. Decision tree. Each time I look at that. Do I understand more or less? If I understand less, then eventually it becomes 0. Then I kind of reject that route. Then you go up, you understand more and more. So I understand 50% of it. Now, do I understand 60%? So I know that it's a gradation.
Yeah.
So it's not suddenly one day you wake up, you understand everything.
So I'm not being, that's fine. But you probably need to work faster to eliminate bad ideas quicker. That would, what they say.
How fast you can do?
What I will do is build it. I will build practical applications.
Like, the way, I'll just finish my point. It'll take like 1 second. In business, I think they call it fail faster, where you try and mess up early on so that you get better quicker and have a better product further down the line. So you need to at some point say, is this really working? And if not, reject it and choose the thing that is working.
Yeah, but the thing is that if you're quick to reject, you may lose the thing. See, the thing is, I think that's a distinction Martin's talking is important, because suppose are you like Trump or Biden? They may not be the correct one. Or in Brexit.
Well, there's no distinction there.
So
there's no distinction there. So the thing is that same way with the people. You hire somebody. Okay, I'm going to hire because that person has written 400 publication, 500 publication. The other person I reject because he has like 50 publication.
Yeah.
I say you reject the 50 publication right away, because 400 has to be some more correct than 500. It's a statistically large number, so he has to be more correct than the person. But I don't look at that way. In fact, I may look at the other way. I will say 500 maybe like a trivial publication, could be trivial. The 50 could be very original. So I choose the 50 publication person. I will hire that person rather than 500 publication person, because
okay,
that
but
will just
that's not like necessary. That's not a counting thing though. But it is. I mean, it is.
The
This is kind of like a logic thing, or like
but the distinction matters. So suppose I say
well,
I accept.
yeah, of course.
No,
Well,
I have this
I
accept and reject, right?
Qualitative rather than quantitative. You're looking at the quality of the work.
No.
Yeah, definitely.
What
rather than the quantity, you're not being like, oh, here's 500 TVs, but they're all broken, and here's one TV that works.
Yeah, exactly.
The TV that works.
Exactly.
It's the quality
this,
of it.
Martin's thing will help, because I say, okay, in the XOR, I might choose the 500 person because he has more publication. The XNOR, when I look at that, the rejection, I will say, oh, wait a minute. This 500 has a problem. He has all trivial things. So he has a high negative thing in that. The 50% has, 50 publication person has very high positive. Now I balance the two. I have close to 50-50. So I'm not rejecting that 50 publication right away. You see that? So I'm thinking, I'm doing a second thought. So I might interview again. I may interview the 50 publication person, and that's a second round. So based on this, I cannot really reject that 50. So I go to the short list that. So I go to the next round. I will call again. I will talk to them or interview them. And I talk to 50 and that 500. Then I get a better picture of what it is. And maybe after 2 rounds, I may be able to decide rather than just one round. You know what I mean?
Okay, that's like if we're trying to find like a theory that works, and like I think we can become attached to our ideas, and then because we get some idea and then we become attached to it, so we want to follow it to the end.
Yeah.
And I find like as a lot of the things I'm working with have problems with them and major problems, and I don't know how to sort them out.
Solve them. That question you should ask
people who came up with it, and they won't respond.
That's innovation. I mean, this is my profession, was obviously in innovation. I mean, it was my profession was all about helping people develop practical solutions to real life problems. So, it's medicines for treat things. It was ways to drill for oil in the North Sea. It was little microscopic nano-sized rotors. So it's really about practical solutions to practical problems. I believe there is a practical problem with
I agree
with our maths, and it's causing inequality, and it's causing our governments to go into ever more debt. It's causing inflation. It's basically the maths that we're using to manage exchange of goods and services is not adequate to control it.
Yeah,
so
we could argue that
more and more.
You could also say that the flaw is like humans, So it doesn't matter what system you use, there'll always be people who'll take more or whatever. So a better system might be one in which doesn't, where people aren't, like, you penalize people who are trying to just grab all the money, and you incentivize people who try and help those who are less.
I think what you mentioned, I think is a very important point. Let me re-emphasize that about the products. So the money is making the people very static. Like, I can sit here lazily. If I have $1 million, I don't have to do anything, right?
Yeah.
I can get whatever I want. What is making is that's the problem. Okay. But I think Martin's thing will solve that problem partially, at least. My feeling. I mean, I have to say yes. I mean, if I say agree or disagree with Martin, I'll say yes. I'll vote yes on that one. Okay. Because
well, I mean, that's
understand
that's
70%.
More the society like incentivizes people to have more money. The more money you have, the more money you'll make.
And then less work. So they think that
money. Wait a second. If you have enough money, wait a second. If you have enough money, you can literally have it sitting in the bank, earning interest, and just live off the interest. Whereas if you don't have money, then you're just gonna have to work for the rest of your life.
Yeah.
Into your pension.
The
So
people
the
have
idea
money,
is to get more money, which kind of sucks. But
lazy. It makes people lazy, less productive. So
well,
your
yeah,
GNP is not going up because
if they're rich,
you have products. You don't have products. You don't have products.
Yeah, but these are huge issues. Like we're trying to go from like something small like accounting, like these are massive societal issues. We'll probably only change at the political level.
Yeah, sure.
You know, so I
agree.
It's just not going to happen. We're not
overnight. We cannot change.
Problems. And we're especially not going to do it.
You cannot change tomorrow. Oh, tomorrow we solve this problem. You cannot do that. That's what I'm talking about.
With understanding
this gradual thing.
That the way we believe in 1-0 is resulting in the privileging of some people over others.
I don't see that at all. Could you explain that?
I can kind of understand it.
That is what I've been doing this whole presentation.
Yeah, but I mean, so we have 1 and 0. Okay, so we have something and we have its opposite or nothing.
So what I'm saying,
either have everything or
it's too broad. Like
you either have
privileging and who's privileged and who isn't.
Very simply. So we privilege XOR over XNOR. We say that the difference between two things that are the same is nothing.
Yeah.
Yeah. So that we've decided to assign absolute meanings fundamentally to 1 and 0 of distinct, countable, and non-countable the same. And in the end, when that way of approaching counting is applied over and over again across billions and billions of people in all the different facets of human endeavor, you are building and building and building inequality, because you are inherently privileging one side over another. And in this case, you're privileging XOR over XNOR.
Yeah, no, I don't. Okay. I don't think so.
And this is where you come to Marx. Marx understood this, but he didn't understand the logic. Marx got this.
Yeah, I don't think that's correct. I don't think for to begin with, I don't know if you've made the point strongly enough that we're using XOR over XNOR. I don't think you've demonstrated that.
I understand what he's talking about.
What is the difference between the two sides of an equation?
Well, we've been through that, but like, what does that have to do with? So what are you talking about?
Between the two sides of an equation?
Yeah, but would you have like? What other thing are you proposing other than that?
No. Just answer. What is the difference between the two sides of an equation?
0.
0.
Yeah, because they're equal.
Yeah, because that's all you can see.
Yes, that is all that there is there not?
No, that's all you can see.
But what are you suggesting other than that?
That whenever you make a comparison, whether the things are the same or different, there always should be two outputs.
Well, we're not making a comparison. We're already established that they are equal. We've already established that they're equivalent. That's why it's an equation. If they weren't equivalent, then it's not an equation. So
let's look at an example. X squared plus 1 equals 0.
He needs to answer that.
Yes. So yes, I would say I don't believe in equations.
So then why did you ask what it was? What difference does it make?
Because that's why you don't understand the logic that I've described to you. It's not my problem, it's yours. You can't
that's fair enough, but that's why I'm asking.
How I've explained to you how the meanings are tethered to the objects, and how you could equally take either meaning and tether it to the objects. And I've explained to you how in a process which is recursive, the meanings can flip between the two. So you can work with both meanings at the same time. So I've explained that very clearly. So you do understand it, you reject it, which is a different thing.
I'm not rejecting. I need to understand it. At this point, I think that, yeah, I think it might be
but you don't like it.
It's like it's too hard to pin down what you're trying to say. So
I think you can. It's too simple for you not to be able to. You do get it, but you don't want to get it.
I'm kind of a little bit bamboozled to this point where I'm not even sure what you did say. So what was it? XOR, privileging XOR. See, well, the question I asked was, what does that have to do with our maths? And then you brought equations into it, and then you said that equations don't exist. So
I'm saying that
now I'm really confused.
I don't believe in equations. Equations are an incomplete description of a system. You need more to have a complete description of the system, and hence to have control of that system.
Well, we do have other things, don't we? Other than equations, such as we could have like something is not equal to. So is that still an equation? I'm
saying you're still
or we can have
trying to understand something.
Then. So it's, what is that called when it's not an equation, but it's like a general statement or an uncertain statement? It's like just greater than. Where you're struggling,
where you're struggling is you've not allowed yourself to step back and say, okay, everything is constructed, so let me look at how this system that's been put before me is constructed. Let me suspend for a moment my absolute belief in nothing and look at how the system I've described actually works. And if you do that, you will find it does. It does work. It will give you counting. It will describe the physical world just as equations do.
Yeah.
But what it will give you is control. And what it will give you in a human setting is an ability to control, for example, an economy and voting and the physical movements, the coordination of, let's say, muscles or a robot. It will give you complete control rather than management, because for something to be permissible, both sides of the logics have to apply at the same time. And the example I gave you by an analogy was with you sold the pen to Trajam, and you got a +1 and he got a -1. Was it either way? Yeah, a -1. And under the current maths, working XOR only, you two can independently interact with the rest of the world and come back to balance, to 0.
Yeah.
But actually, that's the problem, because it shouldn't be possible for you to both independently come back to balance. You should not be possible. You should both have to come back to balance. You can independently interact with third parties so that you do the mirror opposite, one sells and one buys. But until you can close up at the same time, and so you've actually completely switched around, you should not be able to do it. And that is the problem with conventional mathematics and equations. Because it works only in XOR and not in both. If you use both,
personally, I don't think that the issue of like one person buying something off another. I mean, yeah, I see what you're saying. Like if I go and buy something, you know, there's a whole huge system around that, isn't there? Like I have to get the money from somewhere, so I had to work for it.
Just all the pay.
And I have to like pay the taxes, and then I have to pay for the item with my card, and maybe there's a charge from my bank for using the card. But then the bank also had to get their money off a different bank, and then they pay interest on that. and then they push the price on to me and to the shopkeeper.
Cut it right down.
These things. So I think it's a not a great system. It's also a very what's the word? It's delicate, isn't it? The whole thing could collapse. Like the bank, the shopkeeper can go out of business. The bank can go out of business. They can't no longer buy money to sell to you, and then you don't get any food, and so the whole thing is sort of tenuous, really. But yeah, but talking about control. Wait a second. That's a really good point, and I think that's very interesting. I mean, in a sense, science is all about controlling our environment and learning to get the upper hand over it. In a sense, where that sounds a bit much, but to some extent, that is true, and maybe true.
So control, but by control,
you're talking about management. Maybe you're talking about more like how people like how to manage the system fairly, right, and in an equal way, so that no one's being stepped on and everything is good. So really, what we're looking at there, I think. Wait a second. If you're looking into if you're looking into mathematics, because the world is sort of unequal anyway, and if maths is describing the world, then it's going to describe something that's unequal and unfair. But what you're looking for is probably a different system, and I think you're looking for it in the wrong place then, because mathematics is not going to provide you with that. Or at least where you might find it, you're probably more likely to find it in morality. So a system of morals, which is much more complicated.
It is absolutely in the maths.
No, I disagree. I think you definitely need to find it in a place of morals, probably something.
It's because it
religion or something.
What I could do with this maths is I can build.
Yeah,
I could build a system where I can control movement, I can control an economy, I can control drawing a distinction between black and white and color, just by coding, just by the four quaternions. I mean, that's an interesting one. The difference between black and white and color, the primary color, that fits order 4 as well. That's another example.
Isn't there 5 terms in that? RGB, black and white.
So black and white is the presence and absence of light.
Okay.
And then you have the two primary additive and subtractive colors, blue and yellow. What is it? Red and green. And the thing is, you have to get the right combination.
There's only 3 primary colors, isn't there?
RGB.
Not when you're dealing with the additive and subtractive colors.
What are they? Are they not? But they're not primary then, are they? Additive and subtractive.
Yes, they are when they're subtractive.
What do you mean? Sorry, I'm not following.
Okay, so it just depends whether you're adding light or taking light out, whether you're filtering light in or putting it in, and you put color perception. So we're talking about color perception. We're not talking about because obviously with light, your experience of color is a mental construct. It's not there. It's purely a mental construct.
But what is so you're saying? But then wouldn't you have to have 7 if you've got like additive? Because you can add what is it? Well, you can add yellow to. Hang on, this is confusing. You can add yellow to blue to get green.
Yeah.
So why would green couldn't be a primary color or?
No, sorry, no, it's not. So green isn't. It's yellow and blue are primaries, and I've forgotten now what the they're the additive colors, and the subtractive ones are the other way. There's red, and I forgot what I forgot. It's on my website.
There's like purple is another additive. If you add blue and red together, you get purple.
So basically, the point is this: if you, and this goes back to the voting, and I know it's an analogy, but it's important to see this. If you are presented with a black and white world and you're asked to choose between black and white, and you see color, how do you vote?
Well, yeah,
because they are neither black nor white.
All the time in politics and rhetoric and whatever you want to call that world that's there is like they give you 2 options and they say, would you like I don't know, you know, whatever the two options are. And then you could say, well, there's a third option. So they're offering you a false dichotomy, and but it's a game, you know. They're like, you know, heads win. What is it? Heads you lose, tails I win, or whatever. So it's intended to mess with your head.
But in the real physical
and then if you're smart enough to see through that, you don't actually need to know maths to do that. You just need to be trained to know that there's people out there who are going to mess with you and take advantage of you, and that's all you need to know.
Yeah, I checked that primary colors are red, yellow, blue. Red, yellow, blue.
Color is you've got.
RGB is like.
I cannot understand black and white
TV
in terms of color. If you live in, let's say, a blue-yellow world,
yeah,
and your choice, let's say your Brexit referendum was between blue and yellow, and you had to choose, and you see the world in black and white,
yeah,
how do you do it with conventional maths?
I don't know. I don't even understand the question. Sorry, blue and yellow, black and white. Like,
if you're asked to vote blue or yellow, which do you want? Blue or yellow?
Okay.
You see the world in terms of black or white.
Okay. So what color do I see the blue as? Do I see it as black, or do I see it as white, or is it grey?
Well, you see, you're well. It's once you've dissolved one distinction, another distinction opens up, but the components of that original distinction, the blue and yellow, have disappeared, and you've mixed them all up in a new way. So there's no mapping from blue to black and yellow to white. Everything's got mixed up. When you go from the logic gates XOR and XNOR to the other ones, it all gets mixed up.
Right. Yeah.
So how would you deal with a true false question? Same different, the definition of same and different, using and, or, and, or, nor. You can't. You can't do it.
Yeah, I agree. Okay, so that is very interesting. With all of it, like, there's a lot there to unpack, obviously. I'd have to consider it a bit more, perhaps. But
I think. I mean, we'd finish because I can tell my door's being closed, which means that I'm being told that it's time to move on.
Yes, exactly. We've been on for 2.5 hours here. So,
what I have given you is actually, if you study it, is a full and accurate description of a system, a working system. And it explained, but in order to understand it, you have to act like a judge, a Supreme Court judge, if you like, somebody who has to construe a legal document. And you have to start to say, right, a priori, I'm going to start and look at how the terms are defined and then see how it works as a system. And I'm not going to bring to it all my prejudices and understandings of what symbols and things mean. But the biggest one, the hardest one to let go of, is this idea of a hard tether between a symbol and its meaning. But if you do, and you look at what I've given you in that presentation, you'll find that it is an internally consistent description of a system. Now, whether you think that system should ever be tested and applied, that's a different question. But to say it's not understandable, I don't accept, because it is a system. And as a patent agent, I know when I've described something in a patent, because nobody's ever knocked a patent out that I've written. And to put in, just give a bit of perspective. So I would think the patents I've written around the world protecting drugs cumulatively have protected sales of over $100 billion. That's how much confidence my clients have had in my ability to describe their inventions. So I'm very confident I've described in those slides exactly what I wanted to.
Right.
But whether you accept it or not depends on whether you can act like a judge and construe the document in terms of how I've defined things, rather than try and understand it from your own knowledge of what things mean. That it's there. I've given you a gift. It is up to you. But whether you want it or not, that's a different matter. But it does work.
Okay.
It is absolutely sound.
Okay, that is you know, like I would yeah, that's fair, I guess.
So one one clarification quickly, because this will help in going further. I think we will have probably further question and answer. I mean, more. You can take up an example and then like the sheep, and then start and do step by step. At one point, I think Christopher suggested to me that helped me, and then finally he was able to map the algorithm I was giving. And Christian and other people also agreed that I had to work out an example, simple example, which I worked out, and that helped to understand it. The same way you can do it, hopefully. But the main thing I wanted to is, what I understand in overall sense is that what we have is a binary system now. Either you are like 1 and 0, like you have either everything or nothing. Like I have food on my table, or I don't have a food at all. Yeah, binary. But you're talking about a quaternion system.
Binary system where the ones and zeros have opposite meanings, and you work with both at the same time.
That's it.
It's binary, but it's binary and dual, which is why there's 4.
Yeah. So
it's
you
binary and dual. And when you do both together, you have control.
Yeah. You have 4.
Go ahead there,
so
Rajan.
what you are talking about, a quaternion system. And I believe, like true and false, I believe there should be 4 of them. Like true and false, not true, not false. They are all different. So it's very similar, but it's not exactly same as you have. But that's the truth table I believe in. Like true, not true doesn't mean automatically false. Not false automatically doesn't mean true. So you have to have the 4 system. That's why I believe that
it's not false. So it could be what then? What is there? It's not false. So it has to be, if it's only false, then it could either be. Could it be?
Yeah. So you don't. Yeah.
True. And it could be not.
Yeah. So
true. No.
So
what
happens is that finally
I said I'd give you a couple of hours. We've run for nearly 3, which has been great. I thoroughly enjoyed this. But just as I finish up, what I have given you is absolutely described to the same level as if I had written a patent for an invention. There is sufficient information to enable you to take that idea and run with it. You don't actually need any more, but I'm happy to share more with you. But it is absolutely internally consistent. All I ever set out to do was to try to transfer the knowledge, not to persuade you that it's right or not, because that doesn't matter. It is internally consistent. And
well, I think it's a good project, to make people to make people aware that that we can be more equal. There's something needs to change within the system of politics and finance, and because there is I think everyone would agree with you. I certainly do, that there's new problems there. Perhaps your system could help be the solution, or maybe it is a little bit too complicated and like too high level for like the average person to grasp. But at least you're making an effort, and that's what we need. We need more people to what we need everyone really to work together and realize that, you know, we're all in there's no one like that really has it better than everyone else, or like we think that the random shopkeeper that I mentioned has it better because they're charging you on the, you know, with for the money and all of that, but then they have to pay people and those people have to pay people, all sort of interdependent. So that's where like systems like communism come along and start saying, oh well, these rich people, they have it good, so let's take what they have and kill them. You know, like what happened.
And that's not as I said.
That's not. We don't want that.
But I would say Marx was right, but he was wrong, because the problem is actually it's in the dialectics, but it's in the maths, and the problem is simply that the way we distinguish between what is and what is not something inherently privileges one side of that distinction over the other.
Yeah.
And if you treat the two sides of a distinction symmetrically, that goes away. And
yeah.
That's
and the result of that is, I would prefer to think of it as this Zen koan thing, where we just become like the rabbit, and you know, just try and think of it with me. Become the rabbit in the headlights there, and just, do you know what I'm saying?
What
you feel it, Martin? Just indulge me for like a minute. Can you? What I was saying about the Zen koan, you know, so can you reach the point where the two zeros, let's say, cancel out, where come to the point where, you know, it's just, we just don't know or something. Not that we don't know, we do know, but like
I think I've reached the point when it doesn't matter to me whether you get it or not. But if someone asks me, I'll explain it. But I'm not emotionally invested at all.
In this system. Okay, that's fair enough. But yeah,
but it's there as a tool if you want to use it.
Cool. Okay. Well,
and it's there freely. It's freely given. I give it. It's a gift. I freely give my time. I freely give that idea out into the world. And
thank you.
Take it or leave it.
It was a very.
And then hopefully, if you are able to come next week or following week, you are welcome. If you are able to come next week, like half an hour, 1 hour, whatever. You may not spend this much time, but like half an hour, 1 hour.
Next week, I'm afraid I'm up in Scotland, probably miles out of contact, up in the castle.
Great.
So I'm back in a very different world, but and I'm afraid the signal there is very poor. But I will track you and follow you online, and I will be back in civilization within a couple of weeks and be able to pick up on things.
Okay,
but
that's fine.
It's been an absolute pleasure talking with you guys. I've really enjoyed it, and I've really enjoyed what I've enjoyed. Actually, I've also thoroughly enjoyed writing the presentation, practicing it, sharing it with people on the way as I practiced it. I hope you do get to see it, to understand it, because everything's in the first few slides. And if you do, then I think you'll find that I'm actually very much grounded in the physical world, what you call the real world. My whole career has been in science and technology. And if you Google me on the patent side and look at the patents I've written for people, you'll immediately see that my clients were Lilly, Glaxo, Pfizer, you name it, DuPont, General Mills, Cargill, lots of universities. I've done Princeton, I've done Harvard, I've done a lot of the Israeli universities.
You have been.
They've all come to me.
Oh, you have given Princeton and
I understood them, and I've written the patents.
This is more of your hobby, then, I take it, Martin, rather than a.
This is something that I figured it out because it bugged me. I had an emotional reaction. I couldn't understand at a very deep level, a logical level, what I could see. And so I've taken the time to figure it. So is it a hobby? Well, at the time, I filed patent applications all around the world on applications. But you see, things called business methods, anything that's to do with abstract ideas rather than physical things, are inherently not patentable. They actually were when I started filing. They were in the States, and then there was a Supreme Court decision, Bilski, which flipped that. So I had an expectation that I would get a patent on this. And if I had,
Martin is and Rajan, of course, because you live in the States. I thought IP, intellectual property, was a thing over there, is it not?
Yeah, it's a complex thing now, because I had some people, from IT people. I had gathering, like before we did that, I had different set of people gathering. Some of them were in business, some of them IT people, actually going into like Microsoft, Qualcomm and other people. They eventually went there, but I was talking with them, and one Chinese person, eventually I think they joined one of the top thing. I don't know if it's Facebook or something else, but it's a good programmer. But I was talking the IT, they don't generally give patent anymore. That's what he was saying. They don't apply for patent anymore. It's such a complicated system that I also tried a little bit, but I sent to them like copyright thing, that it's such a complex thing that it works only if you have a well-established company, and the company like Intel or Microsoft or something, and they have their own people, and you submit to them, and they get that. Because you as a person, you go as an independent person, it's almost impossible to get the patent because of the complex things.
The big companies have hired all the good patent lawyers. It's very hard as an independent to do it. I did have independent clients, I did get them some patents and defend their patents for them. But yeah, it is hard. Patent law, you think maths and what I've described is complex. Patent law is a whole 2 orders of magnitude more complex than today. It is very good, but it's very real world, because the who doesn't get the patents on what really determines a lot of big business outcomes.
Without a doubt,
whether it's the guiding of a missile or the guiding of a medicine through a little nano robot through your bloodstream to a particular tumor cell. There's all sorts of different technologies, all fabulous inventions, amazing people you meet when you do this.
Right.
The inventiveness of people is phenomenal. I have to say, I particularly like working in the States rather than the UK, because people are much more open to innovation and taking risks in the States. And so most of my clients were in California.
Wow.
In startups in California, Silicon Valley, and South San Francisco.
Great.
They were really very, very innovative, and they took a lot of big risks. Came up with some absolutely brilliant inventions. The Gilead came up with one for viruses. Well, several for viruses. In fact, they were onto the COVID virus before that kind of thing, before it came along, bird flu and so on. I wrote a patent for them on bird flu, treatment for bird flu. So yes, it's out there. I'll just say I am very confident. My head's screwed on. What I've described to you will work, and I have described it fully and completely and succinctly, as I would have done professionally for an invention. And the patents I wrote which are on file. I mean, the publications.
Yeah.
People look at they are there. You can find them on research. I put them on the ResearchGate. You'll find if you look that there are versions of my patent applications in Chinese, Korean, Russian, Portuguese, all sorts of different languages, because I filed them literally all around the world. I was very confident I'd figured this out right, but then the law changed starting in the States, and the system that I described was no longer inherently patentable. There's nothing I could do about it, so I dropped them.
Yeah. Well, I mean, this is it. I mean,
but I'd built a business.
There was at a conference in Turkey a while back. Well, or no, sorry, it was all online. We were watching it.
Oh, yeah, it was originally, yeah.
Myself and Rajan were in the chat, chatting about most of it was finite geometry kind of stuff, and I know a bit about it, but they were at a very high level, and basically to me it just sounds like nonsense. And but I don't think any of them asked each other a question or anything, but and for all we know, so the point I'm making is that yes, of course your system could work, and we just don't understand it or whatever. But there's also but you would need, I'd say, if it is that complicated, maybe the way that you have a proof, some sort of proof that we could just read through it and go, oh, okay, I see, this solves this, and then that would just draw a line under it. Or I mean, another way of doing it might be to just use, I don't know if you're into programming, but just program the whole thing and show that it works.
Yeah, I think I had the exchange completely programmed so you could actually do it. So that was done in India quite a few years ago now. But
you can post your code then on either your website or ResearchGate, and I can take a look at it and see.
It's proprietary with the business that I developed it with. We did a collaboration, so it's not I'm not free to do that because they collaborated with me. I can't give the code away, I'm afraid. It was a business in Aberdeen that I worked with and collaborated with.
Okay.
They and then they were in business. They were a barter exchange business. So I'm not at liberty to do that. All I can do is tell you how the system works, and someone would have to recode it.
Okay. Well, I suppose the best thing would be some sort of proof, but obviously I couldn't help you with that because well, I'm not very good at proofs anyway.
One thing I
really need to get to go. But anyway, just once again,
okay, thanks, Martin.
What I've given you is a complete description, and if you look at it, you will find it is very, very simple. And what you're worrying about as being complex, there's some mental block you've got because it isn't complex. It's very, very, very simple. That's its problem. It is very simple, and that may be the issue. But
just quickly there, Rajan, what were you going to say?
Just two things. One of them is that is it possible you can help with us in the patent process? If you have something, whether you can help with us in the patent process because you are a patent lawyer.
I've stopped practicing patent law. There was a time when I could. I was actually the only person in the UK who was qualified to practice US, European, and British patent law. I was the only person in the country who could do that. I passed all the examinations and was qualified to do all that.
Wow.
I ran my own business for 12 years, and I obtained patents for people in Europe, right across Europe, and in the US. So 80% of the world market for most products I did myself. What happened was the British government changed the regulation of patent attorneys, and that so that in effect a lay British regulator could hear a complaint and determine on a complaint whether I practiced US patent law correctly or not. And I realized that this exposed the business to risk that I found unacceptable, so I closed the business. Because I could see that a small startup in the States could leverage it, not wanting to pay a bill, could have a go at me with a lay person in the UK. So that's why I closed the business. So I've stopped. I'm no longer insured to practice. But
so Rajan, did you
years ago? Yeah, absolutely.
You have something you wanted to patent? Was that it?
Yeah, I mean, I'm just asking. There are a few things I have that I thought, but
yeah, people often have to. I don't do it anymore.
Maybe Martin could send you some like references, people that you could talk to. I think you can actually, if you want to patent something, you can really just you can basically patent anything because it costs money to patent things.
Yeah, that's
so if you go and say, hey, can you patent this? It's like I don't know, whatever. It's
$5,000, $10,000.
Yeah, sure, give us your money. They don't mind.
That's the problem.
Okay. The lawyer fees are the expensive bit. The official fees are quite steep.
Yeah.
The government fees to examine your patent application, but the lawyer fees are humongous.
Right.
And the more complex it is, the more expensive it is. I'm just out of that now. I'm restoring castles.
Oh, lovely. I'm very envious of it. It's a beautiful place in a beautiful area as well. So.
Yeah. So tomorrow we're going up and we're going to go and work on that and we're going mackerel fishing.
What is it?
We're going to go with my nephew and my wife. We shall go up. We shall do some. We've got to harvest some fruit from the wall garden, and then we shall go and do some mackerel fishing, and then we'll cook the mackerel on the fire.
Oh yeah,
that's tomorrow's activity.
Well, that's it. So let's hopefully. I mean, you're going to have beautiful weather anyway because of the time of year.
It's probably going to be pouring, but we'll be fine. Anyway, absolutely talk to you.
Thanks very much for your time.
Again, if you like, but it is
very interesting.
One more, just one more. So some of the things that you talked about, I'll go over. Some of this, I think I can apply. I might reference your thing, but also we might be able to do some publication together. So I can send you email, right, in case you cannot access.
Yeah, you can communicate, and quite frankly, if either of you can see how you can, if anything I've offered you is helpful to you, or you think you can see how I can better present this, maybe with an application, and you want to do a joint paper, absolutely happy with that. I will give you all my energy to do that.
That would be fascinating. I would absolutely love to see your work, maybe with Rajan's. And then just to see how you would tackle the issues of truth and not true and all of these interesting sort of, I wouldn't call them gray areas, but they're like strange area and see what the meeting together of these two systems and see.
Yeah, it's superposition. It's
somewhere in between.
Could it be the rabbit that I'm thinking? I don't know. I'm joking.
Yeah, no, I'm somewhere in between Christopher and you, Martin. Actually, I'm somewhere in between. If you have a set theory, right? You Venn diagram, like Martin is here on one circle and Christopher is here. I am somewhere in the intersection, in the middle, because I agree some other things, and I think I can connect. I believe in that. I think I can connect. I can see, like equations, for example.
I'm a believer in connecting all systems together to create one giant system. So, and that's one of the very positive things about Rajan's methods.
That's why I like the discussion and debate to clarify things and then as clear as possible. And once I do that, I am sure I can explain it, but it will take many sessions to explain all the things step by step. And I am sure, like I said, I use a decision tree. If I am going the right direction, I understand 50%, then 60%, 70%. That's the right trend. That's the way I look at it, the trend. Suppose I am going the wrong way, then I eventually cut it off. I don't proceed that direction. Then I go to a different direction. I think this will work fine. I mean, this will work really well.
I mean, that is a good system as long as you know how. I don't know.
Yeah, I know how to work it. Yeah, I know how to work it.
And then also I hate to, because I'm finding, anyway, with the work I'm doing, I've kind of followed sort of maybe some sort of it's not even a mainstream path, but it was like discussed a lot by mathematicians and stuff. I'm finding a lot of holes in it, but also, I mean, the whole process, you know, because I thought like that when I started working on it, that they had this all nailed down, like that they had some kind of connection between what they do with like matrices and quantum mechanics, and then permutations and quantum mechanics, that's there as well. But I think to a lesser degree and to a slightly more tenuous degree, and then you have quaternions and so on and so forth. And then finally these polytopes, you know, 4-dimensional polytopes. But really, you know, how much does any of this connect, you know? Or is it just sort of mental masturbation, as they call it, you know? So it'd be it'd be interesting to see. Or like, so I'm going to kind of keep going, because I think we're all into, like, we all kind of like systems and how to apply systems. But if they when the logic, when it gets very complicated, as it is with me at the moment, with the I'm working with the 600 cell, which is like 120 vertices, and so all of these things link together. But so then it's like how to create a system where the concordances make sense. So like, Martin, you're talking about counting sheep in a field, and you can count them in any order. But let's say those sheep also needed to go into pens, which actually had numbers on them. And the sheep also have numbers, but maybe you don't know which numbers the sheep have. So you count them in one way and send them into the pens, and that's how you did it. But that might not be the actual way that it's supposed to be. And so these are the problems I'm having trouble with, that I need to solve. And maybe your system could do that. But I don't know of a system at the moment that can, and that's what I'm looking for. It's like,
I think, you want to see these symmetry groups and simplify it. At the end of the day, all a neuron can do is fire or not.
yes,
Everything everything you can conceive of, maths, all the complexity, in the end, codes in firing and not firing in order. Everything ultimately comes down to that. It's an oscillation.
Yeah, does seem to be the case. And then, because that's another issue, is that, well, I was just thinking about the neural networks that we develop and stuff. And it'd be great if those systems could solve the problem of which network goes with which network. But there is what are they called? GNNs? I've forgotten, but it's like basically neural networks for graphs. So they can, you go, this node connects to this node, and then you say, then you give it a node and say, what nodes does this connect to? You know, and it tells you, and that's great. It can do a lot of that stuff. But some of the things I'm interested in is like, could you give it that works fine if you have a lot of nodes, but if you're just working with small symmetry groups that are kind of easy for me to get around, I don't have a deep kind of algebraic knowledge, and personally I don't want it, because I'm not even sure what the heck they're doing at that level. But I suppose they are doing they're finding out like monster groups and stuff, but it's not particularly interesting to me. So
I think if it's a symmetry group, then everything in it, all the components will transform according to the relationships between those elements in that group, which is why order 4, it's 4D. And
order 4 is nice. I like that. Then you can
scramble different ways, but it'll always conform to the same pattern. So each symmetry group, you can see a pattern in it.
I work a lot with.
I think we'll be doing that. He'll be saying, this symmetry group, fermions, bosons, this symmetry group. And it doesn't really matter what you call the elements, how you divvy it up. They will actually transform according to the rules of the symmetry group. But it's a long time since I did all that in chemistry. I mean, when I was doing quantum mechanics and periodic table and stuff, and how it came about.
It's fascinating.
Anyways, I absolutely have to go now, guys.
Okay.
Really fun.
Thanks.
We will. Sure, we can talk again. But
enjoy your holiday.
I've given you honest, hand on heart. It's not a religion. It works. But
thank you.
Try and use it. Try and find a way to use it.
We hope to see you after a couple of weeks, probably. But in the meantime, we'll communicate through email or something. Yeah.
Yeah. Send
Okay,
pattern reports.
Okay, I'm going to hit the studio now and go get something to eat and start to load my car up for and switch to a different mindset now. Okay.
Okay.
Bye-bye.
Okay.
Enjoy yourself. Have a great day. Thank you.
Okay.
Okay.